Today we are going to be looking at the final revision. So meaning that we're going to be discussing about some questions, and then I give you a highlight of what is expected to be in your exam you're gonna write. Uh, if you have any challenge or any question, let me know so that I can help you out. Let me start with some questions I've prepared you so that we can at least have a clear view of what you expect to find in the paper. I'm going to be dealing with all the sections so that everyone, or if you have any challenge on a specific part, then you are helped out. M. Saidi, don't forget to subscribe, like, and also share for others so that they can also benefit. Let's start without wasting time. We have different questions here, and the first question is about organic. Don't forget that this paper, most of the marks are going to come from organic, meaning that we expect you to be passing this paper. And then the other parts you'll find, if you do organic, it's a guarantee that you have passed. I'm talking about the minimum, the mark which doesn't take you to the university, less than 50. So when you have now you add these other sections, then you project your marks to a distinction. So let's focus for a distinction, not just a mere passing. All right, let's start with these questions. They're saying that letter A to D in the table below represents 4 organic compounds. So you have different organic compounds here. So the first question is going to be about this naming, identifying the type of functional group, homologous series, such things. So let's look at it. Letter represents a keton. Which letter is representing a keton? Don't forget that a keton, it has oxygen and 2 alkyl groups, meaning that this can be a carbon and this is a carbon and a carbon. You understand? Doesn't matter how long it is, but this functional group must be in the middle. So in this case, if you look at this, it's no. Check here. This is see the way it is there. You see that that's the functional group, and then it resembles this. So the answer becomes B. So when they ask you about the keton, I think you can differentiate it from the aldehyde and alcohols. Then we got the structure formula of the functional compound of group of compound C. When you look at compound C, they're saying the structure formula. Here is the key point. Don't just write. They're saying the structure formula. So what is the functional group of compound C? What is compound C? So compound C, it is what? The functional group of compound C. If you look at compound C, it is what? It is an aldehyde. So how do we write the functional group of the aldehyde? Sorry. So it's going to be C. Yes, it has an alkyl group with oxygen and then a hydrogen. So these are just the simple questions of which anyone can answer them. So I'm not going to waste too much time. I want to take more time when it comes to the chemical equilibrium, acids and bases, those questions which require more and more calculations. Then we go to the general formula of the homologous series. So look at this general formula. They are looking for the general formula of homologous series of A. Where is A? It is an alkyne. So alkynes, don't forget that you have CN, H2N, plus 2. That is alkane. CnH2n. When you leave it like that, then it becomes alkene. Then CnH2n minus 2, then it becomes an alkyne. So you start with the 2, then you don't talk about the 2, then you minus the 2. So basically, that's how you can remember that structure. So in this case, what are you going to say? You're going to say that, guys, if you have a question, let me know. Please don't keep quiet. If there is a question, I'll try to answer that question out. All right, let's go to, we are saying that, so it means that this becomes the answer for our question, this question which we are talking about, because it is an alkyne. So we're done with that. IPAC name of A. If you look at A, what are you going to label on A? Where is A? So look at this. You have, now let's label it. Sometimes naming it becomes a problem if you don't understand the criteria you're supposed to write. Basically, where is the problem coming from is to identify the functional groups. To identify not the functional group, the side groups. The side groups becomes a very big problem. So you have 1, 2. So this one is on number 2. Number 1, this is 2. The functional group is on carbon atom number 2. 1, 2, 3, 4. The functional group is on carbon atom number 4 if you use this direction. I think now we can find out. All right, now let's count. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I think. So it means that this one has the longest chain comes like this. You see? 1, 2, 3, 4, 5. It means that now this one is on 5. 1, 2, 3, 4, 5, 6, 7. 1, 2. So I'm gonna go with the shortest one. So meaning that if I go with this as the longest chain, so it means that this and this are going to be the side groups. So now let's label it, or let's try to name it, and then we find out. So guys, you should not have a challenge with this. So now let's count. 1, 2, 3, 4, 5, 6, 7. 7 is helped, né? But is the functional group is on carbon atom number what? 1, 2 is on carbon atom number 2 dash 2, and then you say because it is an alkyne, so I'm gonna add Y and E. So it is heptene. So however much if you lose this, what is before here, but you have mentioned this correctly, at least we shall give you a mark. Try and do what you think, where you can get marks, because when you are answering this, we don't answer this all of it, like all of it, then you get all the marks once. You get all the marks once. No, we give you marks depending on what you have answered. So you must not panic because you have lost the longest chain. No. So okay, let's continue now. So if this is heptene, then let's look at now the side groups. So because you have used this direction, guys, don't change the direction. No, you continue with that direction you have used. So now you're gonna be 1, 2, 3, 4. This one is on carbon atom number 4, but it is a what? Which side group is this? It's 1, 2. So it is ethyl, because the side group is eth. So I add YL to show that is a side group. But it's on which carbon atom? 1, 2, 3, 4. So it's on carbon atom number 4. So it's going to become 4 ethyl. Then I continue saying that 1, 2, 3, 4, 5. This one is on carbon atom number 5. So it's going to be 5. How many carbon atom is 1? So it's going to be meth. Because it is a side group, I'm going to add YL. So it becomes methyl. So now I've got to know the naming of the side group, the naming of another side group, and the main chain. Now I have to combine all of them. How do I combine them? I have to look at this, and I look for which one is first in the alphabetical order. I don't change the numbers. I only start writing with the one which starts in the alphabetical order. So now if I have this E and M, I will find out that is E which is first. Therefore, I'm going to say it's 4 dash ethyl, yes, dash 5 now, dash methyl, yes, you see, now heptene. That's how we label or how we name this. How do we name it using the IPAC naming system? So I think I'm clear there. Unless you have a question concerning about it, let me know if you have any question concerning about that. Now let's go to the next question and then we see. The next question is saying that IPAC name of B. What is the IPAC name of B? B is a keton. So since it is a keton, it is simple to write. It must end with on. So it is 1, 2, 3, 4. So it's gonna be 4 is but. You understand? So but 10, and then what is the functional group? Where is it found? Is carbon atom number 1, 2. So it's gonna be but 2 on. Listen carefully. There is something small which makes students fail when it comes to this. Listen carefully and let me give it to you. What makes students fail? Okay. When it comes to alkene, yes, alkene, and alkynes, yes, you say but, prop, then you put whatever you want to put. Eh? But when it comes to alcohols and other homologous series, you don't stop here. For example, this is but2, maybe yin, whatever. Ne? But now when it comes to alcohol, you say butane. You add this until here, then you say 2 or something like that. It is supposed to go up to this point. But if you're talking about alkene, and alkynes, you only stop on but. And when you're talking about the side group, you only stop on but. Like you don't go to butane. You understand? So please also that one makes students to fail. Let's go to question 4.5. Question 4.5. So I think we are done. So it's gonna be but2 on. And then compound D is a gas used in cigarette lighters. You understand? Compound D. Then they're saying that which homologous series does compound D belong? So compound D, let's look at compound D. Where is compound D? Is butane. So to which homologous series does it belong? It belongs to, the moment you say butane, N, it is an alkane because it is derived from there. It's an alkane. So the homologous series is alkane. So they are saying that write down the structure formula and IPAC name. The structure formula and the IPAC name of what? The IPAC name of structure isomer of compound D. Structure isomer of compound D. What does it mean? Okay, they're saying that write down the structure formula and IPAC name of compound D. Someone is asking. All right. They're saying that, to which homologous, okay, IPAC name, write, the compound D is, okay, we are done with that. Write down the structure formula and IPAC name of structure isomer of compound D. So what are you going to write? Where is compound D? Compound D is butane. You understand? But they want the structure, write down the structure formula. They want the structure formula and the IPAC name of that compound D. So what are you going to write here? So compound E is butane. Let's look at butane. It's 1, 2, 3, 4. So it's a butane. So butane is like this. Okay, it's like that. So I'm going to bring about the what? I'm going to bring about the isomer. So what I'm going to bring about, I'm going to bring this and I put it there. So it's going to become 1, 2, 3, 3 because it's 1, 2, 3, and then I can put it down or up. It's the same thing. Make sure that everything is put 4 hydrogens. It must be hydrogen. Don't leave them hanging. It must be, all of them must be hydrogen, hydrogen, hydrogen. Cool. Yeah. So now it has become an isomer of this. So now I have to label it. So what am I going to label? It's 1, 2. So this one is on carbon atom number 2. So it's going to be 2 methyl, because this is a side group. Methyl, methyl, and then 1, 2, 3, propane. That's it. That's what they want. So they will give a mark here, and they'll give a mark here, depending on what they have put the marks where exactly. Then let's go to the next question. They're saying that is isomer, you have mentioned above, positional, chain position, or functional. So what if you look at it, what has changed here? Is it a functional group? No. We don't have functional isomers in alkanes. Yes. So what you have changed here is the chain. You have changed the chain, the structure of the chain. Therefore, it's going to become chain isomer. It's going to become chain isomer. So the answer here takes place. How do we call that type of reaction that takes place there? Because we have substituted hydrogen with bromine, then it's going to become substitution reaction. But which type of substitution? Is going to be halogenation. Which type of halogen? The actual halogen which is being substituted there is bromination. Actually, you have added bromine in there. So basically, substitution is a big one. Halogenation is a little bit bigger or moderately. And then bromination is the actual. If it is chlorine, then it's going to become chlorination. If it is iodine, it's going to become iodation. So it depends on what you have substituted. But if you don't remember all that, just say halogenation, because still they will give you a mark in that regard. Before I go to the next question of this, so that's the first question, is about naming. Make sure that when you go to the paper, you are able to answer a question concerning about that. You understand? The next question which I can talk about here, where students might lose marks, is when they bring a question whereby they ask you for the reaction. I think I will speak about it when it comes to the reaction, whereby they react with bromine, and then this the red color of bromine is what turns colorless. You understand? In actual sense, is decoloralized. Ne? It turns what? Colorless. Yes, as a result of passing through a specific compound. So when the bromine color turns into colorless, as a result of that reaction, it means that that compound had a double bond between carbon atoms, or it had a triple bond between carbon atoms. So alkanes, they will not decolorize. They will not change this bromine water, the red color, into colorless. Never. What will do that is either a triple bond or a double bond. A triple bond can be converted to a double bond, and then at the end of the day, you will have bromine attached on each. You understand? So you need to know that if they bring it in an experiment, you must know that the one which decolonizes must have a double bond, or it must have a triple bond. Okay, let's go to the next question without wasting time. The next question, they're saying that consider the organic molecule or organic compound represented in that diagram. They're saying that A to C below, what happens to A to C? They have given you different molecules. You understand? Yes. So in this case, you have to just a moment, guys. Okay. They're saying that name the homologous series to which C belong. To which C belong. Where is C? C is here. So it's the same example as the other one. It is to which homologous series does C belong? It belongs to the ketones. Check how it is. So it is a keton. Yes. And then they're saying that what is the IPAC name of A? You see, now it's the same question which they brought there. Now it's almost the same thing. So it seems that you won't be able to fail anything related to naming. So what are you supposed to do? First find the identify. Let's just show you how you name it. The same way I named the other one. 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you see, now the longest chain is 8. So is it a single bond? Single bond is out. So it means that this is going to be a side group. Is it only that? We also have this and this. I think. So they are going to be side groups or the functional groups. Ne? So if I count from this side, 1, 2, 3, 4. This one, the first one is going to be on carbon atom number 4. The second one is going to be on carbon atom number 5. What about this? 1, 2, 3. The first one is going to be on carbon atom number 3. The second one is going to be on carbon atom number 4. So I'm going to go with the short one. So now it means that I'm going to have 1, 2, what am I going to say? I'm going to say 3, comma, a figure and the figure we separate with the dash. 3, comma 5, dash, di, chloro, then I add this, dash, 4, dash, methyl, 3, comma 5 dichloro, 4 methyl octane. So that's how we basically supposed to name these organic molecules. Guys, I think it's not that. Do you find any challenge? Someone is asking me that, do you have the memo for how 10 September paper 2? They are writing tomorrow. Why should you ask for the memo? I'll give you the memo tomorrow. When immediately after we are done. Then I'll go through the paper. Yes. Even if I give you the memo, does it mean that you're gonna get a memo on finals? So it means that you're just ruining your life. So guys, let's concentrate on this. Let's go through this, and then tomorrow when you come out of the paper, you come back and tell me a story. Yes, let's go through them, and then tomorrow when I'm going through the paper you're gonna write, tomorrow maybe around the 2 o'clock or depending on the electricity or 4 o'clock. Yes, I'll go through your paper and then you see how you have. Even if you have not passed, still to help you to prepare for the finals. Yes, so don't stress. Let's continue, guys. Let's focus for the future so that we get distinctions. All right. And alcohol and the methanoic acid are heated in presence of concentrated sulfuric acid. The moment you bring about alcohol, and you bring about carboxylic acid, because when you say oic, that's a carboxylic acid. Sorry. The moment you talk about that, you are talking about esterification. It must come into your mind that you are talking about esterification. Okay. So what is esterification? Formation of esters. So it means that you form esters in using alcohol and the ethanoic acid in the presence of heat and the concentrated sulfuric acid. Yes. So what is the role of concentrated sulfuric acid in this reaction? Guys, whenever they ask you, the role of concentrated sulfuric acid is acting as a catalyst. Catalyst. You must know that. Is acting as a what? A catalyst. They are saying that write down the name and the formula of the inorganic product from definitely it's going to be water, because the moment you have alcohol plus the carboxylic acid, you form in the presence of the sulfuric acid, and you heat, you're gonna form an ester plus H2O, which is water. So it means that water is the inorganic molecule they're asking you to write about. And then when they ask you to write the structure formula, even water must be in form of a structure formula. In most cases, people don't write this water when they're asking you to write the structure formula, and you end up losing marks just like that. Okay, let's go to the next question. Name the, okay, we have seen that the inorganic molecule here is going to be water. So they're saying that ester contains 6.7 hydrogen, and then 4 of carbon, 53 of oxygen, and then the molar mass of ester is 60 grams per mole. Use the calculation to determine its empirical formula, and then later you talk about the molecular formula. How do we do this? It's a simple thing to do and to get. So what you do need to do is to find out the elements which are given in this reaction, and then you are able to get. Okay, the first one is hydrogen, carbon, and oxygen. Carbon, hydrogen, and oxygen. And then you need to know the mass of each they have given you. Carbon, they say that the percentage they have given it in terms of, this is 53.3, and then this is 40, and then this is 6 is what? 6.7, 6.67. Is it carbon? It's hydrogen, It's hydrogen. It's hydrogen. This is hydrogen. Okay, just a moment. It's 6.67, and then carbon is 40, and then the other one is 50. Carbon is 40, and then this is 53.77. Okay. 53 point. Am I growing up? 53.33. Yes, 53.333. Okay, now that's the mass, the percentage mass. And then what about the molar mass? Molar mass. The molar mass of this is 12. The molar mass of this is 1. The molar mass of this is 16. Then now after that, let's divide and then find out what is it. When you divide, it's gonna be 40 divided by this, 40 divided by 12, and then 6.67 divided by 1, and then 16. No. 53 divided 0.333 divided by 16. So here the answer you get, I don't know. You have to calculate and find out. This is 3.33, and then because this is 1, it's gonna be 6.67, so it's obvious. And then if you divide here, what are you going to get? It's 3.33. You see? So basically the ratio is gonna be is 1 to 2 to 1. Yeah, if I divide by 3.33 divided by 3.33 divided by 3.33 divided by 3.33 33. So I'm gonna get this more ratio. So now what does it mean? It means that carbon is 1, hydrogen is 2, and oxygen is 1. So that is the empirical formula. But the molecular formula, they say that when you equate this, is going to be 60. Therefore, I'm going to say that carbon, I'm going to put an N here, so that I know. Carbon is 12 plus hydrogen, which is 1 times 2, because there are 2, plus oxygen, which is 16. So what is the answer here? When you add all of them, you're going to get 30. 30, but 30 times n. So it's going to be 30n, which is equal to 60. So divided by 30, divided by 30. So I'm going to get n is equal to 2. So is that the answer? I doubt. Is that the answer? I doubt. So they're saying the empirical formula. We are done with that. The molecular formula, then therefore the molecular formula is going to be C. We say the C. In this case, remember I have N each here. N here because I put it outside here. So it's going to be, C is going to be 2. Hydrogen is going to be 2 times 2 is 4. And then oxygen is going to be 2. So basically, that is the molecular formula they are looking for in that regard. Class, are we together? Let me know. Even I'm writing. I've written already though. Haven't. Or paper 2 is already. I thought everyone is done. No. Someone is saying I thought no, it's not done. We're going to have more classes on this physical science because there are so many people who are basically struggling. Parktown boys, we have written already. Just I wanted to know how well I did. Oh, it means that you wrote a different paper. Yeah, because there are some schools where they write different papers. Ne? Yes, they write what? Different papers. Yes, depending on the school. But thank you very much, Butumelo. Yes, where are you from? Gauteng Metric are writing tomorrow. Yes, Butumelo. Yes, it's Gauteng. They are writing tomorrow. Tomorrow they are writing. But finals, I'll be here, guys, for you. Full swing. Make sure that you prepare questions. I'm here to help you guys. Ne? Tell your brothers and sisters, grade 11, 10. I'm also projecting there next year from 10. Yes. So, all right. Let's continue, guys, to the next question. I think we are done with the first set of organic chemistry. Let's go to the next question. The next question. What is it saying? All right, guys. Ne? Yeah, guys, if you check this physical science, the problem is coming from is that students don't give chemistry time, yet chemistry is the simplest. Don't talk about physics versus chemistry. Physics is much more harder than chemistry. Chemistry is nothing. You just don't have love for it. But since you are here, it means that you have love for it. Ne? I love you guys. Ne? Let's go to the next question. Ne? Life is good if you make it good. Yeah. If you don't like chemistry, how will chemistry like you? Obviously, if you don't like me, I'll also say I don't care, man. All right, but if you like me, I also like you too. So that's chemistry. That's what chemistry is saying. If you don't like it, definitely it will say that I don't like you too. All right, let's leave that and then we continue the next question. I'm saying that the vapor pressure, so this is another question concerning about organic chemistry. So you're done with the nomenclature. I hope you guys are going to get all the marks there. Ne? Yeah. The vapor pressure versus the temperature of the pressure graph below was obtained for 4 straight chains. 4 straight. This is a key point. And branched. So they are talking about it. P, Q, R, and S. From P to Q, P to S, each compound differ from the previous carbon by this. It means that it belongs to the same homologous series. That's what it means, because that's how homologous series, the same homologous series, the members, that's how they keep on changing. They are being changed by just this. The vapor pressure are mentioned in millimeters of mercury. This means millimeters of mercury. 78 millimeters of mercury is equal to 1 atmosphere. Yes. Okay, they're saying the atmospheric pressure is 760 millimeters of mercury. All right, let's continue. Give the reason why alkanes are said to be saturated. Whenever I talk about saturation, it means that they have single bond between carbon atoms. Don't say that they have single bond. Where are the single bonds? They have only single bond. That word only must be put in bold, underlined, and in italics. That's the meaning of how important that only is in that definition. They only have single bond between carbon atoms. They only have single bonds between carbon atoms. Yeah. In other words, they don't have any multiple bond. Multiple starts from 3. They don't have any multiple or double bond. So because if you can say multiple, but multiple starts from 3, what about triple bond? What about a double bond? Still, it is not saturated. So it's better to say that only have single bond between carbon atoms. Anyway, let's go to the next question. Vapor pressure. What is vapor pressure? When you talk about vapor pressure, is pressure exerted by the vapor in equilibrium with its liquid. When we stop there, we're going to cross it. Don't forget that these questions are or you get it or you get nothing. Is or not you or nothing. No, it follows that. Either you get all the marks or you lose it. So now people always say that pressure exerted by the vapor in equilibrium with its liquid. The answer becomes wrong. It can only be correct if you add in a closed system. In a closed system. Yes. Yeah, they are saying that now. Use the information in the graph below above to answer the following questions. What is the effect of increase in temperature on vapor? Obviously, when you hit something, it boils more. The pressure increases. The vapor pressure increases. Don't forget that we say that. Look at it. When you increase the temperature, what about the vapor? At 0, the vapor was here. At 40, check, the vapors are increasing. At 80, what about the vapor? The vapor keeps on increasing. So increasing temperature increases the vapor pressure. In other words, don't say that increasing vapor increases the temperature. No. It's not like that. The temperature does not depend on the vapor. The vapor depends on the temperature. So increasing the temperature increases the vapor pressure. If they ask you to describe something, and then if you give the reason, it means that you are giving more kinetic energy these molecules so that the bonds are breaking and then they can escape now. You understand? And then as they escape, they bound with the walls, and then the vapor increases. Anyway, one is going to ask you that. All right, let's go. They're saying that what is the effect? We are done with that. Increase, decrease. Oh, just choose. The answer is increase. Which compound has the boiling point of approximately 68? This is always. Give a reason for your answer. Okay, let me first clean up here so that we don't mess up. All right. 68 temperature. What are they saying now, man? Which compound has the boiling point? Approximately 68. So you have P, Q, R, and S. So here they are saying that boiling, so it's around here. You see, it boils here. You see, because this is the vapor, this is the atmospheric pressure, it must be equal so that something can boil. They said it here, 760 millimeters of mercury. So it means that whatever is here, it is boiling now. So now, if you look at it, here is the, if this is 60, maybe this is this, somewhere here. That's why they say approximately 68. Give a reason for answer. Yes. What are you going to say? it is the temperature where the vapor pressure of Q equals the atmospheric pressure. Yes, which is actually 760 degrees. So in other words, if you look at the graph, that's where the two intercept. This one intercepts with this. So therefore, that's the boiling point of that. So sometimes when you ask you questions, they're a bit tricky, and then you have to at least to look at what is being given so that you are able to answer those questions. All right, let's continue to the next question. Let's go to the next question. All right. They're saying that which compound has the longest chain length? Which compound has the longest chain length? If you look at the longest chain length, will mean that it has the highest boiling point. Yes. Why? Because the higher the number of carbon atoms, it means that the intermolecular forces of attraction will increase, and then the boiling point is going to increase. Actually, it's S. Why? Even you don't know what is the boiling point based on this experiment. The means that its boiling point will be there far, 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 far. If we project, it will be around 100 and maybe 50, somewhere. Yeah. So they're saying that which compound has the longest chain? Explain your answer. So basically, what you can say that at a given temperature, at any given temperature, basically S has the lowest vapor pressure. If you look at it, né? It has the lowest vapor pressure. No, there is the lowest vapor pressure. Yes, because if you have check, if you check here at this temperature, at any given temperature, check. Let's consider this. Let's consider this. At this maybe 90. The vapor pressure here is, check where it is. What about this one? What about this one? It will be very far. What about this? It will be very far. If I compare this, you see that, and then this one, it will be a little bit higher, and then this one will be higher. You see that this one has the lowest vapor pressure, meaning that the higher the vapor pressure, the lower the boiling point, and the lower the vapor pressure, the higher the boiling point. So basically, that's why we say that this one has the highest boiling point. And then it means that the intermolecular forces of attraction between they are more, or they are strong, and then it requires more heat to break this. Hence, it has a higher boiling point. Compound P has 5 carbon atoms. Let's look at compound P. 5 carbon atoms. Draw the structure formula of compound P. Write down the APAC name. Compound P has draw the structure formula. Wait, because they said something here on top, and they say that they are straight and branched chain. You see, but what do they want? They don't want compound P. They want the isomer. So what I'm going to do? 5 carbon atoms. Yes. How many isomers can it form? 5 carbon atoms. How many isomers can it form? It's 1, 2, 3, 4, 5. Okay. 5. Isn't it? So the molecule is like that. But they're saying isomer. So I can bring this here. It becomes an isomer. Or I can bring it's now it's gonna be 1, 2, 3, 4. And then I put another one there. So the rest are hydrogen. You see? That's the first isomer. I can still bring this here, and then it becomes 1, 2, 3. I put there, and I put there. I change it into, is a primary, into a secondary, or into a tertiary. You see? I put, guys, you must always put hydrogens here. Yes. Done. So it can either be this, or it can be this. Depends on what I want. Let's go to the next question. IPAC name. So you choose whatever you want. So it's gonna be 1, 2, 3, 4. So it's 4. So it's gonna be butane. Ne? But it has a side group which is methyl 1, 2. So it's gonna be 2 methyl butane. Oh, this one is gonna be 1, 2, 3. 1, 2, 3. 1, 2, 3. So it's gonna be propane. But it has two side groups, which is methyl. So it's gonna be 2 methyl 2 dimethyl propane. Simple. Let's go to the next question. Let's go to the next question. This one is also about the boiling point, vapor pressure, but it requires you to explain the intermolecular forces of attraction. Yes, at least you need to explain the intermolecular forces of attraction. So what is boiling point? We have seen it, that basically vapor pressure, a boiling point. What is exactly, we say that make sure that you talk about the vapor pressure equal to atmospheric pressure, and it must be in a closed system, and this vapor must be in the dynamic equilibrium with its liquid. So basically that's how you can get the mark. Then you're saying that curve P, that's bad manners. What is bad manners? You just got the question without reading the statement. You always get 0. Relationship between boiling point, and the number of carbon atoms of straight chain alkanes and carboxylic acid, alcohol. Oh, carboxylic acid, alcohol. Okay, sharp. They're saying that now. Graph P, write down conclusion that can be drawn from the above results. P, where is P? For graph P, write down the conclusion that can be drawn from above results. Basically, as the number of carbon atoms, let me check number of carbon atoms. As the number of carbon atom increase, the boiling point also increases. Don't say boiling point increases, leading to increase in the number of carbon. As the number of carbon, because this is independent, this is dependent. As the number of carbon atom increases, the boiling point also increases. Identify PQR that represents each of the following. Alkane. Remember that alkane has only London forces. Alcohol has London force and and hydrogen bonds. Ne? Yes. And then carboxylic acid has dipo hydrogen bonds and London forces. You understand? So it means that now it's able to have a higher boiling point. So definitely this is gonna be carboxylic acid, then this is gonna be alcohols, and then this is gonna be alkanes. Yes, because of the boiling points are low. They're saying that represent each of the following. Alkane, we have seen it. Alkane is gonna be P, and then carboxylic acid is gonna be C. Explain the answer you have mentioned above. Yes, because alkanes, they only have London forces, which require less amount of heat to break the intermolecular forces of attraction. Hence, their boiling point is low. While carboxylic acid has London force, dipo force, and hydrogen bonds, which require large amount of heat to break those intermolecular forces of attraction. Hence, their boiling point is a little bit what? Is a little bit higher. Yes, I think I'm clear there. Let's go to the next question. Now we are done with the physical properties. Now this one I'm just going to do one question regarding to the reactions of this organic molecule. Then after that we can go to other questions until we reach the is there any question? Let me check and see. There is no question being asked. If there is no question, let's go to the next point. Guys, if you have a question, let me know. Ne? Mutumero, do you have any question? Mutumero, are you here? I don't know how you call it. Boy Tumelo. Okay. All right. Just a moment. Technology. All right. They're saying that the diagram below shows how alcohol, yes, P, can be used to prepare other organic compounds. A to E represents different organic molecules or reactions. X, Y, and Z are organic compounds. Okay, sharp. Let's go. Then they are saying that A, what are they saying? Okay, here you have an alcohol which is a secondary alcohol because the carbon atom with OH has two other alkyl groups. Okay, sharp. This one when is alkane. What about this? When I add this is alkene. When I add the hydrogen, then definitely it's going to become alkane. And then even the condition you can see it. You're adding hydrogen, and then compound X, bromine. So this is substitution because I'm adding this. Then if I'm taking it back, it's gonna be still hydration. Is still substitution. But when I go to this, then because I'm gonna remove the hydrogen, the bromide, so it's gonna be dehalogenation. So it's gonna be elimination. So okay, now let's go to the question. Is P primary, secondary, or tertiary? Is a secondary alcohol. Okay? Why? Because the carbon atom, this carbon atom with the OH group, yes, has two alkyl groups, or it has two carbon atoms attached to it. They're saying that write down the type of elimination that takes place at A. So where is A? Is A. So from here, from here to here. So I have, so meaning that alkene, meaning that I introduce a double bond. So it means that the water is going to be removed. Therefore, it becomes dehydration. And then they're saying that, so we're done with that. Additional reaction that is represented by B, where is B? From here to this. So it means that I'm adding this alcohol. So I'm adding from double bond to an alcohol, meaning that I'm adding water there. OH. Let me just say OH. So it means that I'm hydrating. So meaning that the answer here is gonna be hydration. Then I go to elimination that is represented by D. So because this compound was, I want the compound to be like this. So only to form like this, yet it had a halogen on it, and it's one halogen. You see, it is one halogen. So I'm gonna remove the hydrogen and the halogen. So it's gonna be D because I'm removing. So I'm gonna say D. What am I removing? I'm removing a hydrogen. So it's gonna be dehydro. Yes, and I'm removing a halogen. So it's gonna become dehydrohalogenation. So I'm removing the hydrogen and the halogen, hence the name dehydrohalogenation. Then we go to the next. Sodium hydroxide is used as one of the reactants. Sodium hydroxide. Yes. Okay. So sodium hydroxide is used as one of the reactants. Where? Okay, write down. Where? Oh, here in this reaction C. Let's look at reaction C. Let's clean up this so that we see exactly what they are saying, so that we don't get confused. C. Yeah, sodium is used as the sharp. In this case, it means that it's sodium hydroxide. Sodium hydroxide. What type of reaction that takes place there? When sodium hydroxide is used. So from here to here, you understand? It's basically you are substituting a halogen with the OH, meaning that you can say it's a substitution reaction, but because we are using this, then it can also be hydrolysis, or you can say substitution. Yes. And then they are saying that write down state 2 reaction condition for this reaction. So what are you going to say in this case? This is sodium hydroxide. But how about sodium hydroxide? It can either be concentrated sodium hydroxide or dilute sodium hydroxide. Because it is a hydrolysis, therefore it's going to become dilute. So the sodium must be dilute sodium hydroxide. So, or you can say dilute strong base, because sodium hydroxide is a strong base. Yes, so dilute sodium hydroxide or strong base, and then we can have sometimes we heat or moderate temperature, mild heat, or warming up, mild heat. Yes, or sometimes you can say addition of water. Yes, to change from a halogen into an alkyl, you require the sodium hydroxide or dilute strong base, and then mild heat, and then plus you can say just add some water there so that the reaction can take place. Then we got the next question. They're saying that write down the IPAC name of X. Where is X now? X, yeah. How do I know that X has this number of carbon atom? It's because of the number of carbon atoms we started with. So it means that I'm going to be able to know how many are they. It's 1, 2, 3, 4. So definitely it's going to be replaced here with a bromine. So it's going to be 1, 2, 3, 4. So it's going to be butane. Ne? But it's gonna carbon atom number at 1, 2, 1, 2, 3. So it's going to be 2 bromo. Yeah, 2 bromo butane. Basically, that's what you are going to write. 2 bromo butane. Question, write down the formula of inorganic reactant needed for D. Where is D now? Where is D? It's here. From here to alkene. From haloalkane to alkene. Basically, here we add either sodium hydroxide or potassium hydroxide, so that now this sodium hydroxide, the sodium hydroxide can remove the bromide. Yes. So that's what you can write. That's the inorganic compound we are talking about. Use the structural formula. That's where the problem comes from when students they are asked to write the structural formula. Use the structural formula. Write down the balanced equation for E. Where is E? Yes, from this to this. Don't forget this is hydrogen. So you'll find out people adding that like that is wrong. It becomes wrong. Let's look at it. What you are supposed to write. So basically it's going to be, remember all of them are going to be 4 carbon atoms. So it's going to be 1, 2, 3, 4. Even the one which I'm going to form is going to be 4. Isn't it? Yes, I'm going to add the hydrogen plus hydrogen. Remember, even hydrogen must be in that formula. You see? Yeah. So basically, what am I going to add? It had a double bond. Let me check and see. Yeah, it will use mechanical fluid and then sharp. So it's going to have a double bond. So the double bond is going to be there. The rest are hydrogens. You put them hydrogen. You put hydrogens the way they are supposed to be. Because I'm adding hydrogen, so it's a simple thing. Yes. This one must also be like this. So you put hydrogens out, so that you get a mark there, you get a mark there, and you also get a mark there. I think it's 3 marks, né? Let me check. Yeah, it's 3 marks. So basically, that's how you can get those 3 marks. Then we go to the next question. Write down the APAC name of Z. So Z, where is Z now? Oh, the product. So what are you going to write here? The product here is simple. 1, 2, 3, 4. So it becomes butane. Simple. Butane. Let's go to the next question, which is now more calculations. So now section A, or the organic questions related to organic, they are done. It means that you are able to answer all those questions concerning about that. You understand? Question A is what? Is done. So let's continue to the next question. Tomorrow is saying, yeah, I'm here. All right. You know, but tomorrow you are my daughter, né? So when you are not here, yeah. When I say you are my daughter, and Elana from Parktown says they didn't write the same paper. They didn't write the same paper. There are some schools which write separate papers. They write separate papers. Yeah, they are given. Different schools can write different paper depending on how do they perform. Yes, only finals is the same. Yeah, only finals. Yeah, that one there is no doubt. There is no debate about it. Yeah, there is no debate about it. Yeah, I think I'm clear there. All right, let's go to the next question, guys. If you have any question, let me know. If you don't have a question, let's go to the next question so that we smash it, so that we go to the chemical equilibrium, acids and bases, and then we finalize with the electrochemical cells and electrolytic cells. All right. It's saying that the reaction of zinc and the excess hydrochloric acid is used to investigate the factors that affect the reaction rate. Guys, this word excess is very, very important in this question. Very important. Why? Because this cannot be a limiting factor. Whenever you say excess, it means that it cannot be a limiting factor. So you have to put focus on it. There is a question which is going to be related to it. Yes. So guys, make sure that at least you focus and then look at why did they say that excess. They're saying that balance equation is there. Zinc plus hydrochloric acid give you zinc chloride plus hydrogen. The reaction condition used and the results obtained for the for each experiment are summarized in the table below. And then there's same mass. This word same mass of zinc is used in all experiments. The zinc is completely converted in all reactions. Then the reaction time is the time taken. They're saying reaction time. They're not saying the rate. Time taken for the reaction to be complete or completed. All right. And then they're saying that experiment number 1. Yes. Experiment number 1 and experiment 5 are compared. 1 and the 5 and the 5. So they compare. So they selected those two. Okay. Let's see what they're saying so that we can know what they're saying. Write down the independent variable. Write down the independent variable for experiment 1 and the 5, because they're saying experiment 1 and 5. Guys, let me say this clearly to everyone, whether you are here or you watch this later. Question concerning about rates of reaction are one of the simplest questions to answer, but they are one of the most difficult questions students have failed because it is an application question. So please take note whenever you are answering these rates of reaction questions. Please don't rush. Sometimes we hide something and tends the learner to. There is a simple research I did. It was from 2008 until it was 2018. Yes. The most failed question was that. Yes. So under my research, I found out that. So I need to now to check and see what is happening in these years where I didn't do the research. So please don't be a victim for this. Ne? Yes, let's continue and then so that at least we answer those questions. So they're saying that question one, okay, this and this is the same, this and this is the same, you see. So they cannot affect, it's powder. So what is affecting? Is temperature. Let me see the temperature. Yes, the temperature is affecting. So what is independent there is the temperature in this regard. What? No, this question is, this is not supposed to be zinc. It's not supposed to be hydrochloric. State of division for hydrochloric powder. There is no hydrochloric acid is a powder. It's supposed to be zinc chloride. I think the people, where am I putting it to? Yeah, it's supposed to be zinc chloride. Yes. So, so that's the answer. The answer is 10 in that regard. Yes. The answer is what? Is 10. Do I say 10? The answer is not 10. The answer is temperature. They're saying define the rate of reaction. Change in the concentration of reactant or product per unit time. When you say is the rate of change in the concentration of product or reactant per unit time, the answer is wrong. Can I repeat? When you say is the rate of change in the concentration of product and reactants or reactants per unit time, the answer is wrong. Because you are saying rate, which means time. So you are repeating the same question. So when you use rate, you don't use per unit time. You understand? But why do you use rate when they ask you to say rate? What is rate of reaction? Why are you using the same word they have asked you to define? So it's better to say that it's the change in the concentration of product per unit time, or is a change in the concentration of reactant per unit time, or is there is a change in the concentration of product or reactant per unit time. Yes, so I think I'm clear there. Please don't be a victim for that. We go to the next question. They're saying that write down the value of x. Where is x now, man? X is here. Oh, is there any other? How am I going to get this? Okay, let's compare this and this. They are the same. No? And this. Okay, let me underline it. This and this is the same. This and this. Don't forget that temperature. This is hydrochloric acid, but they say it here. They say that hydrochloric acid is already in excess, meaning that increasing this volume it will not do any change. So definitely this is 14. You see, it's an application question. You have to, see how you manipulate that question. Yes, because you see how excess is used now. They are saying excess. They said excess. So increasing any volume of that doesn't change anything because they didn't say they have increased the concentration. Yes, the concentration is the same. So increase in the doesn't change anything. Yes, yes. Then we go to the next question, which is Maxwell distribution curve. Yes, for particles. Experiment 1, 3, and 5 are shown. Okay, A, B, and C that represents experiment. So they want you to identify A, B, or C that represents experiment 3. So how are you going to identify this? Okay, let's come back here. They said experiment 1, experiment 3, and experiment 5. So they're saying that which one? Let me see this. What time is 25? Experiment 3. No, time is 7, time is 5, and time is 4. Okay, now they're saying that experiment, give the reason. Which one is experiment 3? Which one is experiment 3? So if the question comes like that, let's look at the temperature. Which one is experiment 3? 3. Look at the temperature. Temperature, no. I don't think so. Let's look at 1, the volume of the concentration of this. Yeah, this one has a higher concentration. Yeah? And this one has a higher temperature. But temperature, okay, if I say temperature, you'll see that is going to fall more on this side. Yeah? So definitely C is going to be for temperature, which has the highest temperature. And then the one which is on more particles, so it's going to be the one which has the highest concentration. So basically 3 is going to be B, because it has the highest concentration, more particles are trying to what? To react, has the highest number of moles. In other words, you see that its moles are a lot. And then 5 is for the temperature, so it's going to be C. Why are you saying that? Because it has the highest temperature. More particles will have more sufficient energy. It will have more sufficient energy. You understand? Yes. So that now the reaction can what? More will form products. Why? Because the energy those particles they're having, they are more than activation energy. So more particles will become products. So that's why you see that here. Do you see how these questions are a little bit tricky? And because they're not straight out, so people, they tend to lose it. Experiment 6 is now conducted using a catalyst. Experiment 6 is now conducted using a what? A catalyst. So what happens about the catalyst when it's applied? The rate of reaction is going to increase. So the same reaction condition as experiment 1, meaning that same reaction condition. So they're asking you, how will heat, what is the function of the catalyst in this experiment? To speed up the rate of chemical reaction. That's it. To increase the rate of chemical reaction. That's it. How will the heat of reaction in experiment 6 is going to be the same? Because the catalyst does not change anything. It only alters the speed at which the reaction is taking place. Therefore, the answer is going to be equal to, yes. Calculate the average reaction with respect to zinc in number 2. So what are you going to say here? The average reaction. So now you have to know, because zinc, you find the number of moles, yes, of which is mass over molar mass. I have the mass. Therefore, number of moles is going to be equal to 1.5 divided by zinc. Zinc is 65 from the periodic table. Okay? So the number of moles is going to be equal to, you find is maybe 0.023. Use your calculators, then this is moles. Did they say the number of moles? No, they are looking for the speed at which it is taking place. So this experiment is that? Experiment number 2. So experiment number 2, the final time is 14. So meaning that is going to be change. So it's going to be change rate, don't forget, is equal to change in the product or reactant concentration over change in time. Over change in what? In time. So it's going to be 0.023 minus 0. Yes. Final minus initial. Then divided by 14. That's the final. 14 minutes minus 0. So after that, you divide this by this. So the answer you get is around 1.65 times 10 power negative 3. But now these are moles per minute, because this is measured in minutes, unless you had converted it into seconds. measured in the minutes. Unless you converted it into seconds, then that's when you can talk about that. Okay. Is there any question you would like to ask or to know about before I go to the next question? So that's rates of reaction. Sometimes we ask you a question concerning about rates of reaction, and we ask you that what are some of the factors which affect the rate of reaction? So you have to know how to deal with that. The factors which affect the rate of reaction, you have to know all of them, and which one affects the gases only is pressure. Pressure occurs in what? In gases. So please make sure that you know at least that. When we go to the next question, yeah, it's about still the Maxwell distribution curve. This one, the reason why I like it is because whenever they bring it, students tend to fail. They tend to fail. Let's go to the next. Started a Maxwell distribution curve for this reaction. Your PQR, all right. The shaded area, those are the particles which have sufficient energy to form products. And then the unshaded area, those are the particles which don't have sufficient energy. Their energy is not equal or more than activation energy. You understand? Yes. So when you do the temperature, you will see that most of them, they will go, more will be there. And then when you do the concentration, it will increase a little bit up because you have increased the number of what? The number of particles. Yes. So you need to know when the temperature is applied, when the concentration is applied. You need to know how to redraw that graph. So P and Q are labels for axis. Okay. What quantity is represented by Q? By P. So you have said it. P is the kinetic energy. It shows the kinetic KE, kinetic energy. And then Q shows the number of particles or number of molecules. We don't know whether they have sufficient energy or we are just talking about the number of molecules as we go up, the number of molecules in this reaction. You understand? Yes. R represents the minimum energy required for the reaction to take place. Write down the term under this. We call it, how do you call that energy? The energy is called the activation energy. You understand? Then they're saying that write down the term. Okay, we are done with that. How will the shaded area of the graph be affected when the catalyst is added? Choose, increase, decrease, or remain the same. How is this shaded area? When you apply a catalyst, you are lowering the minimum energy required for the reaction. You are giving it an alternative pathway, which is a bit quicker. Yes? Yeah. So it's like they ask you, you are going to, for example, to Europe. You can use a plane or you can use a boat and then use the ocean, sea. So, but sea is going to take you longer and energy. So when I bring you a ticket for the plane, is an alternative way to reach there. Simple and easy. So when you apply the catalyst, you are making an alternative way how you can reach there. And many are going to do that. Check when you're using Istimera, the train. The train. You're using the train to go wherever you want to go, or you are using the taxi to go wherever you want to go. How many people in the train? And how many people are in the taxi? You see that people in the train, there will be a lot going because it's a little bit cheaper. So that's what catalysts do. They give alternative. Therefore, you will see that more individuals here, they will be having a lot. You will be having a lot of them. Yes. When the catalyst is what? Is applied. So basically here is going to be increased. Why? What I can say, catalysts provide alternative pathway or lowers the activation energy. You understand? More particles will have sufficient energy, and then you're going to have more effective collision per unit time. That's what the per unit time. You don't write it, you lose it. More effective collision per unit time. You understand? And then this increases the collision. Then this increases the rate of what? Reaction. So basically, that's how you can explain using the collision theory. Yes. Before I go to chemical equilibrium, let me check. Yeah, I still have a bit of power. Electricity went a long time. I hope it will make me survive. So before I go to chemical equilibrium, because now you are going to chemical equilibrium, so that we can also tackle it. We can also tackle it, and then we see what we can do. And they're saying that I'm from District 11, Gauteng. I'm asking because I see some from Gauteng school saying they. Guys, stop that habit of some. Anyway, they wrote you have not. Let's focus, guys. Let's focus. Let's focus. There's everyone has a destiny. So our destiny is tomorrow, and we have to crush it. We have to crush it. We have to crush it. Yeah. All right. Don't stress about those people who have written of which you will never write the same paper. Yes. Yeah. You will never write the what? The same paper. Okay, guys. Before I go to chemical equilibrium, let me just talk about this simple graph. I think you know it. You know it very well. When I have a graph like that, what does it mean? It means that this is it. You start from a low energy to a high energy. Therefore, it is an endothermic reaction. When I have this graph, you start from a high energy to a low energy. Therefore, that's exothermic. You have released energy to the surrounding. How do we call this? A and B. These are products. These are reactants. C plus D. These are products. But this is for reverse reaction. This is what? Reactant. This is product. How do you call this energy? This is the activation energy. This is the activation energy for the forward reaction. But from here to here is activation energy for the reverse reaction. So you have to know all this. Yes. And then change here. It's basically the enthalpy change. Did I say yes? The energy products have, and then here the energy reactants have, and then when I have this difference is the enthalpy change. So you guys, and then you have here the top here, the species which are always here, we call them activated complex. Is a complex which is in the transition. It's not a reactant and it's not a product, but it's in the transition to form products. So when they ask you what's the activated complex, is a species which is in the transition of forming products from the reactants, meaning that they are not yet products and they are not yet what? They are not reactants. So guys, let's continue to the next question, and then we see what we can do to, yes, chemical equilibrium. Yeah, chemical equilibrium. Guys, any question? No question. All right, let's go to chemical equilibrium. They're saying carbon dioxide reacts with the carbon in a closed system. Carbon dioxide reacts with the carbon in a closed system to produce carbon monoxide, according to the following balanced equation. So this is what you have. What does the double arrow indicate in this above equation? What does this double arrow indicate? The double arrow indicates indicates that the reaction is reversible. It's a reversible reaction. You understand? Yes. Is the reaction an exothermic or endothermic reaction? Basically, this reaction is an endothermic reaction. Why? Because the enthalpy change is greater than zero. It's an endothermic reaction. It takes in heat. This is what I said here, that if the enthalpy change, you start from here and then you end up, it is endothermic reaction. Start up and down, it is exothermic reaction because it releases heat. Guys, when you take a deep breath, how do you feel? You feel good, man. You feel relieved. You know how you are relieved? You took energy out. Even you feel that you are releasing the energy, exothermic. You were hyper, now you go down. You feel cool. That is how exothermic reactions are. They start from up, they go to the low. But if someone makes you angry, what happens? You feel, you feel it. You feel the heat inside you. Yes? Why? You are collecting the heat. You are absorbing. You feel like yes, that's the meaning. That's when you're going fight. That reaction is called endothermic reaction. You are taking in heat, and that reaction, when you are cooling down, then is an exothermic reaction. Yes. Anyway, and then when someone comes, okay, let me read it. Let's go to the question. Yeah, so it is an endothermic reaction. Reason why? Because the enthalpy change is greater than zero, or the enthalpy change is positive. What does double R? Okay, we done that. Initially, a known amount of carbon dioxide is exposed to hot carbon. Hot carbon, okay? Initially, this is very important. Container at equilibrium, and then the reaction at this is this, okay? The Kc is 14, and then they're saying that equilibrium found that this is the number of. So you see what I'm highlighting. This is what is given. You need to know that before you go for any calculation. So they're saying that how will the equilibrium concentration of the product compare to that of reactant? Choose from equilibrium concentration of product compared to that of the reactant. Definitely, because the Kc is greater than 1. Yes, therefore the product is going to be more. Look, if I have Kc and then I have product is 2 and then the reactant is 1, what is the Kc I'm gonna get? I'm gonna get 2. What about if I have the Kc, the product is 1 and then the reactant is 2? I'm gonna have 0.5. So if the products are more than the reactant, the Kc is gonna be above 1. And if the products are less than the reactant, the Kc is gonna be less than 1. So in this case, the Kc is 14. Therefore, I'm going to say that the products are more than the reactant. I think I'm clear there. Then I got to the next question, which is calculate the initial mole of this. So how am I going to calculate the initial mole? All right, this is what you're going to do. Let's use our rice method. It depends on what you have been using. Let me draw it here so that you see exactly as I'm calculating, you see exactly what you are supposed to use. So if I say I'm going to use my rice method, rice, I like to add another E at the end so that I know the concentration. Rice, so in this case, they say that what is the reaction? They're saying that carbon dioxide reacts with the carbon, giving me this, but this is a solid, so I scoop it out. Therefore, it's gonna be carbon dioxide. It's gonna be carbon dioxide. It's gonna give me carbon monoxide. You understand? So carbon dioxide is reactant and carbon monoxide is the product. Mole ratio it's 1, and then here it is what is 2. What is the initial mass? What is the initial? We don't know. Let me call it initial. This means ratio. This means what you started with, the initial. So in this case, we don't know because that's what they are asking us to calculate. They say that calculate the initial amount of moles of carbon dioxide. So let me call it X, or I can call it Y or Z, whatever. Yes. And then here, products, they always start with 0 unless they say it that maybe they added at this, they added. You understand? So what is at equilibrium? At equilibrium, we don't know. And then here, so what is used, we don't know. C means what concentration and what is being used. And then E, what is at equilibrium. You understand? So how am I going to get this? I don't have anything here. I don't have anything here. But they gave us here a clue here that they say that 16 grams, 168 grams of carbon monoxide is present when at equilibrium. So these moles are present here. But these are grams, so I have to convert it into moles. So I'm going to say that number of moles is equal to mass over molar mass, of which mass here is 168 divided by the molar mass of carbon monoxide. Carbon monoxide is 12 plus 16. 12 plus 6 is 8, is 28. Ne? Yeah. It gives me 28. Ne? Yeah. 28. So when I find the number of moles here, the number of moles is going to be 6 moles. You see? So it means that what I used, what I produced is 6 moles. What was at equilibrium is 6 moles because these are product. But now, since this is what is there, ne? So I need to know how much is there because this is what is used. Ne? So it means if I have 6 is 2, 1 is going to be what? Is going to be 3. So now it means that I can find what remained at equilibrium. Therefore, I'm going to say x, this minus this, I get this. X minus 3, so that I get what is remaining here. So at equilibrium, the concentration at equilibrium is going to be 6 divided by the volume. The volume was given here is 2 divided by 2, so it gives me 3. And then here is going to be x minus 3 divided by 2. You see? That's how you keep on calculating. So you make it a table, eh? Yes. So now it means that the Kc, which is equal to 14, they said it here, is 14 is here, is equal to, the concentration of carbon monoxide, but the concentration of carbon monoxide is 2, is 2, so exponential 2, and then carbon dioxide is 1. So of which this one is gonna be 3 squared divided by x minus 3 divided by 2. You understand? After that, now you guys are mathematicians, you can calculate it. Ne? Okay, 14 is equal to, I reciprocate this. Ne? I reciprocate it and then it becomes 3 squared is 9. Ne? 9 times 2, I bring this one up, divided by x minus 3. You can use any method, yes, of which this is 9. Ne? This is 9. So which is going to be, I bring this one this side, so it's going to be 14x, then 3 times 14, 3 times 14 minus 14 times 3 gives me 9 times 2, which is 18. You see? So you calculate and find out what is it. So this, I bring it this side. You see? I bring this side, and then I get what is x. The x I get is actually what is here. So it's approximately 2. Is it 2? No, it's approximately 4.28. 4.28. 4.28. So that is the number of moles. Yes. What is here? So that's how you guys are supposed to keep on calculating. We bring these questions in 3 phases. We can bring this question when we have hidden the concentration. The problem is here. We have hidden the concentration of the reactant, or we have hidden the concentration. We don't know the Kc, or always the problem is here. So what you need to do is initial minus what is remaining. In most cases, we get it from this side, you get what is remaining at equilibrium. So you divide, then after that you can replace it in the, or you can substitute it in the what? In the expression, so that you get the actual answer. It's saying 3 not x. Sir, where does x come from? Okay, Rumelo is asking me, where does x come from? Okay, let me show you. I said x here. Yes, I said x here because they say that we don't know the initial amount. Check, they say calculate the initial amount of carbon dioxide. Carbon dioxide is here. It can't be 3. If it was 3, then it would have been, you see. So I said x. I just gave it unknown. It can be x, it can be p, it can be z, it can be o, it can be n. I just used x so that I can introduce this x, the initial, and then the 3, because I started with the, I produced the 6 carbon monoxide. The mole ratio is 2 to 1. Therefore, if the 6 is 2, and then 1 is going to be 3. You understand? So that now when I subtract this 3 from this, I remain with what I remain with at equilibrium. That's why I said x minus 3, which is used. I will know now, once I get this, I will know what remained at equilibrium. You understand? I hope, Boitmero, you understand where I got the x from. Sir, do you mind to do more Casey questions? Amber, I don't mind any. I'm not minding anything. Yeah, as long as it is helping you guys to, let's do more questions about Casey. Yeah, because I know that Casey really, it becomes a problem to my students and other people's students. But the moment you are here, you become my student. So I'll do more questions now. Let me go to the next question. But I just pray that 37%. The system is having 37%. I hope by that time electricity will be back. But let me do another question about Casey so that at least you don't lose it. If it helps me to go for more questions, well and good. If you see me going offline, yeah, okay. Here is another question for Casey. I put more than enough for Casey because I know that Casey, all the versions they might bring. Yes. Question below represents the hypothetical reaction that reaches equilibrium in a closed system or container. After 2 minutes, this is the question. This is the key point. At room temperature, X, Y, and Z represent the number of moles. X, Y, and Z represent the number of moles. Yes, X, Y, and Z. They don't represent the concentration, they represent the number of moles. The graph below shows the number of moles of reactant and the product versus the duration. So define the dynamic equilibrium. When you talk about dynamic equilibrium, we're talking about the stage in a chemical reaction whereby the rate of forward reaction and the reverse reaction are equal. You understand? The reverse reaction and the forward reaction is the stage. It's a stage where in a chemical reaction whereby the reverse reaction and the forward reaction are equal. So I think I'm done with the dynamic equilibrium. Use the information on the graph, write down the value of x, y, and z. So if you look at this value of x, where is x? Oh, x is a. Oh, a. And then y is b. And then z is z. Z is c. Okay, x. Okay, so here, this one is 4. So b is equal to 4 at equilibrium. Eh? And then A is 8. Isn't it? Yeah. And then C is 12. C is equal to 12. So if I divide by 4 here, by 4, I'm going to get 1, I'm going to get 2, I'm going to get 3. So it means that A is X. A is X. Let me rub off here. A is X. Ne? So X is going to be, A is X, is going to be 2. Y Y is B. Yes, so B here shows it's 1, and Z is C, which is 3. I think I'm clear there. So just a small interpretation which is needed there. Calculate the case C value for the hypothetical reaction at room temperature if the volume of the closed system is. So we have the closed system. You understand? So it means that we're going to use the same method of, let me now write here so that you see it clearly. Ne? Yeah. So Rice method. I wrote the other side last time because just to show you how it works, but now let me use this. Rice. I say that the last E is just for concentration. So what do I have? I have A, B, and C. All of them are aqueous, so it means that they're gonna apply. I have A, B, C. But what is the product? A and B are reactants. So meaning that these are reactants, definitely. So number of moles, A, we say that A is 2, B is 1. A is 2. Sorry. A is 2, B is 1, C is 3. So I know now the molar ratio now. You understand? What did I start with? I need to know what I started with. I started with what here? What did I start with? I started with 0. Obviously, it's the product. Yes, I started with 0. Check here. You see it? And then B, I started with 8. And then this one, I started with 16. Is it? I started with 16. Yes, I started with 16 here, which is A, and B, I started with 8. You see? Let me just show you properly. You see? Yeah, so it's simple there. So it means that, I'm forgetting now. B is 8, A is 16. B is, I started with 8, and then here, I started with 16. Yeah? Yes. Okay, now, I know that now. It's simple. Now, what is the balance? Go to the question. At equilibrium, A is 8, B is 4, C is 12. A is 8, B is what? B is 4, and then C is 12. You see, it's just flowing. They can give you a question like this, simple like that, and then, but this one just to interpret the graph. And then now, what is remaining at equilibrium? Definitely this is the product, so it's going to be the same. Here I'm going to subtract 8 minus 4, which gives me 4, and then here I'm going to say 16 minus 8, which gives me 8. So it's the same thing here. It's the same thing here. You see, it's the same thing here. X3. Then you see, then you subtract this from this. You see, that's the meaning. You see, Butumero. You see what I was meaning here. It's the same thing, but this question is just open. It's an open question whereby it's easy to get the values. So now I go to find out the concentration at equilibrium. Concentration, I have to divide by the volume, of which the volume, they say that the volume is 2. The volume is 2. Where is the volume? The volume. Oh, is the volume 2? Is container? Yes. Yes, I'm looking for the volume now. They say volume is 2. They say that, yeah, volume is here. It's 3. It's not 2. So meaning that 12 divided by 3. So I get 4 there. And then here, 4. Yes, divided by 3. So I get the answer there. You get the answer there. And then 8 divided by 3. So you get the answer there. I don't have a calculator to do that. You can calculate out. Let me check and see. So whatever you get here, now you put it in the KC value, KC expression, whereby in this case it's gonna be C is the product, né? And it has 3. Concentration of C, which is 3, over concentration of A, and over concentration of B. But A is 2. So it means that I have to square A. So now you substitute what you got here in this, and then you find the Kc value. I think I'm clear there. That question is also cool, né? Then Amber, I think I'm clear there. Should I give you more question? All right. Should I give you more question on the? Okay, let's do the last question on chemical equilibrium, so that at least, guys, your happiness is my happiness. When I see you passing, it's my happiness, né? Yeah, because I will know that at least I've changed someone's marks. Maybe by 1, even if it's 1, it's fine. It's fine. The day you get 79.3, 0.4, whereby you are not only 1 mark, it's just 0.01. You know that for a distinction 0.01, and we can't give you that 0.01. Sorry, the system can't. Let's go to the next question, which is 18. Question 18. Saying that 3 grams, guys, whenever they give you the mass, such mass, before you do anything, convert it into number of moles. You converting it is a mark because you're going to use it. So you just come here and say number of moles is equal to mass over molar mass. I don't even know what is there down. So what I need is, so number of moles is 36 divided by of steam. Steam is H2O. You understand? So H2O is 1 times 2, then plus oxygen, which is 18. Oxygen is 16, making it 18 divided by 18. So I get the answer here. At least I know the number of moles in there. You see? So you get it even before you do what? Yes, before you do any calculation. You understand? Yes. So when you divide there, maybe it's going to be around 2 moles. Yes, at least you'll get a mark there. Anyway, let's continue. Certain amount of carbon were placed in a 2D cylinder. This is important. Sealed container allowed to react. At equilibrium, it was found out that the amount of carbon changed to this. The amount of carbon, yes, changed to 2.225. You understand? Yes. So carbon and this, remember, we're not going to use carbon, but they have the same mole ratio with the carbon dioxide. Therefore, I can use that as a starting point for me to calculate. You understand? So I'm gonna come here and I say, that carbon. Let me use my rice method. Yeah. I hope you will get it. RICE, whereby I have the elements here, whereby they say that, what did they say? Is the steam, hydrogen, and carbon dioxide. Because this is a gas, I don't take this because it's a solid. Please don't include the solids there. Okay? So I'm going to have steam, water, plus hydrogen. Yes. So it's going to give me carbon dioxide. Is it hydrogen is going to, no, man. Hydrogen is also a product, né? Yes. So it means that, what am I going to do here? I'm going to say, this is carbon dioxide. So carbon dioxide starts with the 0, is a product. I'm wrong. Sorry, né? This is mole ratio. Let's look at the mole ratio. The mole ratio here is 1, 2, 2. So it's 1, 2, even this one is 2. So what I started with the product 0, 0. I started with the product 0, 0. But I calculated the number of moles of this, because they say that It's an amount of carbon dioxide placed in this container. This, it means that this is the initial. Well, the initial mole is 2. So we get a mark for that. So I put a 2 there. Is it clear? But they say that at equilibrium, what happened? They found out this, meaning that this is the amount of I'm gonna find for carbon dioxide because it is 1 1. The mole ratio is 1 1. So I'm gonna say 0.225. That is what is being used. And at equilibrium, I'm gonna find the same thing, 0.225, because it's a product. Né? What you find at equilibrium is what is produced for the case of product. You understand? But now this one is 1 mole. What about this? It's gonna be 2 moles. You understand? It's gonna be what? 2 moles. So what I used here is gonna be what I used here. By the way, even this is a product, so it's gonna be the same thing. Yes, it's gonna be the same thing. It's gonna be the same thing because this and this are products, except this one. This side is the reactant. Now, since I know that, then I'm gonna find the mole ratio here is 2. If this is 2, oh no man, sorry guys. Just a simple thing here. Yeah, I'm a human. Yeah, because this is 1, yes, 1 more, then this one is gonna be 2. So it means that you have to multiply. So when you multiply by 2 here, it's gonna be 0.45. Yeah? And then even because it's 2 moles, here is 1 mole. So I'm using this. Yeah? So 25, yes. Now, if this is 0.25, 0.45, why 0.45 here and here? Because these are products. So what is produced is what is equilibrium. But this is a reactant. What is used minus what you started from, you get what is remaining. So in this case, since the mole ratio is the same, so it's going to be the same figure, 4, 5. But now what is remaining is going to be this one minus 2. So 2 minus 0.45. You understand? So it gives me what's the answer here is going to be 0.775. So this is the figure we are looking at. So now after that you find the concentration at equilibrium, 0.775 divided by 2, because the volume, they say that the volume is what? The volume is 2. So divided by 2. So I go to this 0.45 divided by 2, 0.225 divided by 2. So the answer I get, I put it in the expression for Kc. Kc is equal to carbon dioxide. Is it carbon dioxide? Is it carbon dioxide? Yes, carbon dioxide. And then hydrogen, but hydrogen is squared because it's 2 divided by H2O in aqueous in gaseous form, which is 2 there. So now you substitute this, and then you find the Kc value. And the Kc value, you'll find it's there, indicated there on the paper that I put it there so that you know. So when you calculate, you must get that actual answer. So yeah, that is the answer you're supposed to get. Yeah, I think question concerning about chemical equilibrium, we have tried to exhaust them. Okay. He's saying that, but sir, we have 2 reactants and 2 products. Yes, Butumero, we have 2 reactants and 2 products. But the reason why I'm saying 1 reactant is because carbon is in a what? In a solid state. When we are in chemical equilibrium, we don't talk about liquids and solids. So this one, check this state, it's a solid. So we remove it out. So we don't consider carbon. If it was in a liquid, if you see the reason why they put this one into a gaseous form is because they wanted to use it in the equilibrium. If it was in a liquid state, we would have scooped it out also. Then it means that we would have used hydrogen and carbon only. You understand? Yes. So in this case, it's like that because we wanted to wanted to remove carbon because carbon is in a solid state. That's why I have two products there. Okay, thank you since you have seen it. All right, let's go to the next question and then maybe we can see, because I see the battery is killing me here. And I still have, I think 16 minutes. I hope in those 16 minutes, actually we'll be back and then we can talk about it. Okay. They are saying that, in this question, they are saying that give reason why the rate of forward reaction, the graph below shows the forward reaction and reverse reaction with the time. Give a reason why the rate of forward reaction decrease between 0 and 1, 0 and 1, T1. Why is it decreasing? Because you are using up the reactant. Yeah. I usually give such examples. For example, let me say, because let me see, people have commented. Yes, Amber, for example, for tomato, for example, if you have 1 million rand and then that 1 million rand, you use it, and then you remain with the 10,000. Do you think that you're gonna spend it the same way you are using it, you are spending when you are still having 1 million rand? No, because you have used it is now decreasing. The speed at which this money is moving out of your account is gonna be low. It's the same thing here. Yes. So it's like that because why? It's because there is a decreased concentration of the reactants. You understand? Yes. Then they're saying that temperature T2, what change made at equilibrium at temperature T3 here? Both changed at the same pace. So it means that there was an application of a catalyst. You understand? Yes. Is the forward reaction exothermic or endothermic? Is the forward reaction exothermic or endothermic? So what are you going to say here? Is it exothermic or it is endothermic? Don't forget it was steam. If it is steam, it requires heat. So definitely, it is endothermic. When you added it, you increase the temperature. Check. If you increase the temperature here, what is happening? The temperature made it to become, the temperature will favor the forward reaction. That's why you see that the product became more product and then the reactance started to decrease. So you see that the forward reaction was endothermic. Why? Because increase in the temperature will favor the endothermic reaction. You understand? Increase in the temperature will favor the endothermic reaction. So let's go to the next question. Oh, the next question is about acids and bases. Yeah, the next question is going to acids and bases. So guys, before I continue, yes, I'm going to give you a short break. But in this short break, I'm just going to, because now I see that the battery is dying. I'm gonna come back at 6, 6 o'clock. I'm gonna come back. Why? Because of the electricity issue. But let me just give you a little bit of what? Of electrolytic cells. Yes, electrolytic what? Electrolytic cells. Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel. Volatile cells. Last time we talked about electrolytic cells. We say that electrolytic cells
for them, they require external battery. So if it requires external battery, it means that they are not spontaneous. They cannot continue on their own. So they have to be with an external battery which can supply energy to them. And we say that an electrolytic cell, it changes electrical energy into chemical energy. And then the voltaic cell or the galvanic cell, yes, this one, it's the reverse to electrolytic cell. A galvanic cell, it changes the chemical energy into electrical energy. It means that it produces electricity. All right, let's start. So we are saying that a galvanic cell or a voltaic cell is a cell in which chemical energy is converted into electrical energy. It means that use chemicals to produce electricity spontaneously. It means that without any external source. It means that these chemicals are converted into electricity. A cathode is positive. Remember, in electrolytic cell, cathode is negative. And then anode is negative. Remember, in electrolytic, anode is positive. So remember that electrolytic cell, it is the reverse of the galvanic cell. Reduction takes place at the cathode. This one remains the same as even in electrolytic cell. And then oxidation occurs in anode. Still is the same thing with the electrolytic cell. Strong oxidizing agent is put on the cathode. When you say oxidizing agent, guys, don't remember, when you say oxidizing agent, how about it? What is happened to it? It means that if it is an oxidizing agent, for it, it is reduced. Receive electrons from what? From a strong reducing agent, which is put on the anode. Anode is negative. Then it means that the strong reducing agent, for it, if it is a strong reducing agent, then it means that it is oxidized. It is able to release the electrons. It increases in the oxidation state. When you lose electrons, you become more positive. You become more positive. Yes. When you give credits to others, you become more rich because you know that anytime that money is going to come back to you. All right. So we are saying that we put it on the anode. So you have to understand this, because if you don't understand this criteria, then you won't be able to understand the concept of voltaic cells. So I will say that this is a red card. This is a red card. This is a red card. So don't forget that. I'll tell you what it means. All right. So we are saying red card. What does it mean? Reduction at the cathode. Reduction at the cathode. Consider, now we are going to have an example. We are going to have different examples. Consider copper zinc cell. If you look at them, you'll find out that one is more reactive, one is less reactive. If you look at the reactivity series, this one is less reactive, this one is more reactive. A strip of zinc metal is placed in the zinc ion solution. A strip of copper is placed in a separate beaker in aqueous copper 2 solution. So you have copper, you have zinc metal in zinc solution, and then you have copper metal in copper 2 solution. All right, here is an example. You have zinc, so there is a reaction which takes place here, and there is a reaction which takes place here. Yes, we say that zinc is more reactive. It is oxidized. It can release the electron easily. Therefore, it causes this one to be reduced. So this one becomes a strong reducing agent. Yes, strong reducing agent is supposed to be at the anode. Then copper is less reactive. We're going to look at the reactivity series. And then copper is less reactive. Yes, if it is less reactive compared to zinc, then it means that it's ready to receive from zinc. So copper is ready to receive. To receive what? Electrons. You see them? See them, yes. You see them. Yeah, electrons. So it means that zinc is going to cause this to be reduced. Therefore, zinc becomes a strong reducing agent. It's supposed to be at the anode. And then copper is going to receive the electrons from zinc. Therefore, it's going to be reduced. Therefore, we will say that copper has caused the zinc to be oxidized. Therefore, we shall say that copper is a strong oxidizing agent. Why? Because it has made zinc to be oxidized. That's the meaning. So this is the half cell for zinc and half cell for copper. These two bakers are connected by a salt bridge. Salt bridge is very important in giving these two cells ions. We're going to look at them and you will understand them better. All right. Should we continue? Yes. So we are saying that they have reaction that occur in each half cell. This is what happens. We say that zinc is more reactive. Yes, it is a strong reducing agent. So it means that for it is oxidized. You start from zinc, the charge is 0, and then here the charge is 2, positive 2. Yes. So it means that this zinc gives out zinc ion plus 2 electrons. This equation must be balanced. Yes. You see, why do we put a 2 here? Because this is positive 2. So if it is positive 2, yes, this positive cancels with the negative, and then the equation becomes neutral. Remember, matter is neither created nor destroyed, but can be changed from one form to another. Yes. So your equation must obey that law. And then copper is going to receive these electrons. Yes, it is copper solution. Yes, it's going to receive the electrons. Yes, these electrons from zinc, and then it forms copper. There is something which is supposed to be noted here. If zinc dissolves to give zinc ion plus electrons, it means that this zinc electrode reduces in size. It means that the anode always reduces in size. Why? Because it dissolves to give out the electrons. It is supposed to be reducing in size. Then copper receives these electrons. Yes. And then what happens? What is happening? The ions here, the electrons from the zinc combining with this copper, yes, to form copper to ions to form copper solid. It means that copper, the copper will increase in size. You see, it will increase in size. Why? Because it forms a solid. Yes, and the cathode is always increasing in size. There's something we need also to understand better. Because now the copper ions are being used from the solution and then form a solid. Why? Because the copper ions then start cancelling what is. So I check what is before the arrow compared to what is after the arrow. Zinc solid, this side before the arrow. Do I have it? I don't have a zinc solid. I leave it. I go to copper ions this side. Yes. Do I have copper ions this side? No, I don't have it. I have 2 electrons. Yes, I have 2 electrons here. Do I have 2 electrons here? Yes, I cancel them out. So those ones, they go. I come this, the ions. Actually, if they can conduct electricity, then it means that it can release the ions and electrons. Providing an electrical contact, it means that it is there is a contact. It's not physical contact. It means electrical contact. Then it means that ions must be exchanged there. It's like an exchange. Functions of salt bridge. Number 1, to complete the circuit. Simple. Anode and the cathode are being connected. That salt bridge must be there so that the circuit is complete. Number 2, it keeps the 2 electrolytes in the 2 half cell separate so that they don't mix. They must not mix. However, it ensures electrical neutrality. So these 2 must be neutralized. If they are not neutralized, then it means that the cells will be impaired. The cells will not work. They will not work anymore. So what they do, they bring about charge, it brings about ion exchange. It brings about an exchange. So by doing that, it ensures that an electrical neutrality is obtained in that cell, so that the ions are neutralized, so that the cell can continue working or functioning normally. All right. Number 3 is allows movement of ions between the two electrolytes from the cathode cell and then the anode cell. The two must be able to communicate with one another, even if there is a distance, so the salt bridge connect them. Note, electrolyte in the salt bridge must contain ions which are weak. They must be weak reducing agents and must be weak oxidizing agents. The reason why they must be like this, so that they don't take part in being oxidized and being reduced. Because if they take a part in being oxidized and being reduced, then it means that they are going to be used up. So then the reaction will stop. So they must be strong, so very weak reducing agents and must be very weak oxidizing agents, so that they are suppressed by the other ones. This will ensure that ions are not oxidized nor reduced, but act as a spectator ions. So it's just like to neutralize, to bring about neutrality. It's just like that. Nothing else. It's just to connect. So these are the functions of the salt bridge. 1, 2, 3. Let's continue. Very simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning.
Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
So today we are looking at the standard electrode potential. The reactivity series is a list of substances which are arranged in order of their ability to act as reducing agents or oxidizing agents. So now we are going to look at which one is a strong reducing agent, which one is a weak reducing agent. And then if you know that, then you know how to interpret the reactivity series, then you will be able to know which one is going to be on the cathode, which one is going to be on the anode. So we are saying that a table of standard reduction potential can be used to, number 1, we're going to look at that table and interpret it better. Number 1, identifying the oxidizing and reducing agents. So we are able to know that this is a strong reducing agent, this is a strong oxidizing agent. Number 2, writing a balanced redox reaction equation. You can be able to write this, predict whether the reaction is a redox, yes, is taking place spontaneously or not. So you can predict whether this redox reaction is spontaneous or it's not spontaneous. It can continue without an external battery. It can continue without an external source, power source, or it can't continue without an external power source. That's the meaning of spontaneous. And then you're saying that you can calculate the EMF, electromotive force, that is EMF, of this cell. So basically, this is the formula you are going to be using. This is the formula you're going to be using. Electrode potential of the cell is equal to electrode potential of the cathode. Remember, the anode is the negative terminal. So the positive terminal minus the negative terminal. So we need to know which one is supposed to be at the cathode and which one is supposed to be at. Now, look at this. If you are comparing two of them, for example, calcium and the copper. Yes. Calcium is at a top level, while copper at a lower level. The one which is at a top level is supposed to be the anode. You must know that. It's supposed to be the anode. And then the one which is at lower level, is supposed to be the cathode. So that's why you see that as you go up, the reducing agent increases the strength. So as you go up, it becomes more strong. It becomes more reactive. It becomes more easily release the electrons. It can easily release the what? The electrons. Or electrons can be easily released. So it becomes a strong reducing agent. A strong reducing agent is supposed to be at the anode. Yes. And then a weak reducing agent is supposed to be at the cathode. Why? Because this one is positive, this one is negative. So this one gives electrons to this. So now we are going to compare copper, yes, copper with hydrogen. So I will come here and say hydrogen is here, yes. Copper, you have copper 2 to copper 1. It's not yet fully reduced. The one which is fully reduced is this one. So I have hydrogen and the copper. So which one is going to be at the cathode? Which one is going to be at the anode? We said that the one which is on top is supposed to be the anode. The one which is down is supposed to be the what? The cathode. So now I will say that hydrogen is going to be at the anode. So it's going to become the negative electrode, the negative electrode. And then copper is going to be at the cathode, the positive electrode. What about when I compare hydrogen and zinc? We have seen here that now here hydrogen is at the anode and the copper is at the cathode. What about hydrogen and zinc? You have zinc here and then you have hydrogen here. So it means that zinc is more reactive than hydrogen. Therefore, zinc is going to be at the anode while hydrogen is going to be at the cathode. You see? So the one which is more reactive must be at the anode. The one which is less reactive must be at the cathode. The one which is on top, even if you don't read this, it's fine. The one which is on top is more reactive, is easy in releasing electrons. You must have that concept. The one which is on top is easy to release electrons. So this one, it easily releases electrons. You understand? So it becomes the anode. And then the one which is below hydrogen, it becomes the cathode. It means that it's easy in accepting the what? Electrons. So let's go back to determining the standard electrode potential of copper half cell. Here you have the copper half cell. You have hydrogen this side, you have copper this side. We don't know which one is the cathode, we don't know which one is the anode. Now, how do I identify that this is the cathode, this is the anode? This is what you are supposed to do. Hydrogen and the copper. Hydrogen is more reactive than copper. So what does it mean? Hydrogen must be at the anode. Copper must be at the cathode. I go back. I have to find out. So we say that hydrogen is more reactive than copper. So this one becomes my cathode. Why? Because hydrogen is more reactive than copper. And then the one which is more reactive, the one which is above the reactivity series is supposed to be the anode. The one which is below the reactivity series is supposed to be the cathode. This is a negative terminal. This is a positive terminal. Negative terminal give out electrons. Positive terminal receive the electrons. You see? Now I'm going to go to identify which one is a positive, which one is a cathode, which is an anode. Now I have to know which reaction is happening on each. If this is negative terminal, yes, and it gives out electron, so I have to show a reaction here where the electrons are forming. It means that when hydrogen comes, yes, it's gonna react here to form hydrogen ions plus electrons. Yes, these electrons will move to the cathode, where copper is going to receive these electrons, so copper 2 ions, plus these 2 electrons to form copper solid. You see here, hydrogen comes in, yes, It forms hydrogen, hydrogen gas. It's supposed to have a gas here. And then hydrogen ions. So it dissolves here. It reacts here at the platinum. And then it forms hydrogen ions, which is aqueous, plus 2 electrons. These 2 electrons, they move. When they move, they come to copper. Here you have copper to copper solution. So I will start with this. Yes. So I will say that I have with the anode. Yes, when you write the serial notation, I have hydrogen. Yes, the hydrogen. This hydrogen goes to platinum. So I have hydrogen gas, comma, it goes to platinum because I don't, this platinum shows that this is just an electrode. But if, okay, I'll explain it. It is showing just an electrode. So this hydrogen, the hydrogen gas, comes to platinum. Yes. When it comes to platinum, it reacts, you see, it reacts to form hydrogen ions. So it reacts to form hydrogen ions. Are you seeing? Which is aqueous. Then I've completed this one. But in between here, we have a salt bridge. Remember I said that the salt bridge is indicated by a double forward slash. So forward slash, then I go to copper. So when these electrons come, they will find the solution here of copper. Yes. So this copper to ions, yes, which is aqueous. Yes, it will give me copper solid, which is this. So basically, that's how you're supposed to write it. In this cell notation, we don't balance the equation. You don't put the 2. No, you just have to write what is really happening. But in the net cell reaction, we balance. It's supposed to be balanced. That's why you have here only hydrogen ion, and yet here you have 2 hydrogen ions. Let's look at another example. So we have said that this is zinc. The reaction is talking about zinc, measuring electrode potential of zinc to iron, zinc to iron in the system. All right, what happens? So now I have to know, this side I have hydrogen, this side I have what? I have zinc. Now I don't know which one is the, don't cram, I don't know which one is a cathode, which one is anode. So we have to go back to the reactivity series, and then we see zinc versus hydrogen. Zinc is here, yes, versus hydrogen. Hydrogen is here, yes. So it means that zinc is more reactive than hydrogen. So it means that zinc is going to be the anode, while hydrogen is going to be the cathode. Let's go back. So now, if you are saying that now, we have understood that zinc is the anode, is the negative, it's more reactive anode. Which one is on top? Anode. And then the one which is at below becomes the cathode. So this one becomes negative. So this one becomes positive. This one becomes negative. So this is anode, this is cathode. This is anode, this is cathode. It means that this one gives electrons to this. So let's interpret. It shows that zinc is going to react, yes, to form zinc ions. Then these 2 electrons are going to move, yes, to go to hydrogen electrode. You see? Now, what happens? The hydrogen ions, which are in the solution here, yes, are going to accept the 2 electrons from the zinc to form hydrogen gas. That's how it's supposed to be. We find oxidation. This one is oxidized from zinc, which is 0, to zinc to iron. It's oxidized. So it releases electrons. Electrons will travel to this. Now, this one is what? Is now negative. It shows that now it can continue on its own. Yes. This, yes, it means that it's a strong, this one, it shows that is a strong reducing agent. If it is negative, it shows that is a strong reducing agent. If it is positive, it shows that it's a weak reducing agent. So basically, that's it. So how do we write this full cell equation or net cell reaction? So you have You're supposed to start with the anode, then you end with the cathode. In this case, this is the anode, and then this is the cathode. So let's see. Zinc, yes, which is zinc, this one. For the arrow, plus 2 electrons, plus 2 hydrogen ions, which is this. Electrons have cancelled, giving me hydrogen after the arrow, plus zinc 2, which is after the arrow. That's how you're supposed to write. Cell notation. Remember, you start with the anode. So zinc, which is a solid, yes, is oxidized. Yes, is oxidized, or it dissolves. This electrode dissolves to give zinc 2 ions. So zinc, which is a solid, is oxidized to zinc 2 ions. Yes. So now I don't have anything this side. Then I'm separating this by a short bridge. Slash, yes, when it goes here, these electrons, they will find the ions here, or hydrogen.
Today we are going to be looking at the melting point, the boiling point, the vapor pressure of these organic compounds. So this program is being brought to you by Thunder Movies. You are with Saidi, who is going to be taking you in this class. Let's look at some of the terms which we need to define. Number one is the melting point. Melting point means the temperature at which the solid and liquid state of a substance are in equilibrium. What does it mean? It means that the rate at which the solid turns into a liquid and the rate at which the liquid turns into a solid must be equal, which we call equilibrium. Then we have what we call the boiling point. Boiling point means that the pressure at which the vapor of a substance is equal to the atmospheric pressure. The vapor produced, the pressure it exerts, must be equal to the pressure exerted by the atmosphere. And then we have vapor pressure. Vapor pressure means the pressure exerted by the vapor in equilibrium with the liquid or solid in a closed system. So it means that the vapor must be with its liquid or the vapor must be with its solid. They must be in equilibrium. So the amount which is being converted, the rate at which these two are being changing from maybe vapor to liquid, liquid to vapor, and then solid to vapor, and then vapor to solid, they must be in equal rate. That's why we call it equilibrium in a closed system. So if you look at this, you'll find out that you have first system, second system, third system. You have the pentane here, you have pentanol, and then you have pentanone. Here you find out that here, because of the kind of functional group which is here, a lot of atoms are being produced. So the atoms, these atoms, because there are many, they exert more pressure than this one, which produce fewer atoms, and this one pressure compared to this one because of the number of atoms. So these atoms, they exert a force on this. So, and then the rate at which this one goes up and then this one goes down. So the pressure exerted when that situation exists is what you call the vapor pressure. Vapor pressure. So let's look at the factors which are the factors that affect the boiling point, the melting point, and the vapor pressure. The first one is strength of the intermolecular forces. This one can be determined by the functional group. So here you will find out that you have a different function group, but you have examples. For example, you have the alkanes, the haloalkanes, or and then the alcohols. So it means that you find out that this one is a little bit weaker compared to this, and this one is a little bit weaker compared to this because of the properties each of this compound has. You find out that this one has London forces or temporary London forces, temporary dipole forces. You have permanent dipole forces, and then this one has weak hydrogen bonds. So the weak hydrogen bonds are stronger than the permanent dipole forces, and the permanent dipole forces are stronger than the weak, the temporary dipole forces. So you'll find out that this kind of functional group, the functional group it has, the type of functional group will affect the boiling point, melting point, and the vapor pressure. Number 2 is the number of the functional group. How many are they? If you look at this, you'll find out that here I have 1 functional group, 2 functional group, 3 functional groups of the same kind. So if it has 1, it means that the boiling point is going to be low. If it has 2, the boiling point is going to be a little bit higher than the one which has 1. And then if it has 3, you'll find out that the boiling point is going to be higher compared to these 2. So the number of functional group, as long as other factors are kept constant. So the length, another one is the chain length or the mass. As long as the molecules are of the same, they have the same functional group, all of them, they are straight, other factors are kept constant, then it means that each atom you add, the carbon atom, it increases the mass, and the higher the mass, the higher or the stronger the intermolecular forces of attraction. It means that this one will have a higher intermolecular forces of attraction compared to this one will have more compared to this. If it has a higher intermolecular forces of attraction, it means that its boiling point and melting point is going to be high, and the vapor pressure is going to be down, because they work in opposite way. We'll see that in detail. And then lastly is the branched chain. This one will depend whether it is straight chain or it's branched. Why? The straight chain has a higher boiling point and melting point and a low vapor pressure compared to branched and compared to the one which is more branched. Why? Because this one exposes a high contact surface, higher than here. So we have more intermolecular forces of attraction because of the high contact surface. It's easy to arrange these ones than arranging these ones, and then it's easy to arrange these ones than arranging these ones. So the particles are too far, so they require less heat to break them, or require less energy to break them, so that they can turn into substance which is boiling, or it can turn into substance which is melting. And then it means that if the boiling point and the melting points are low, then the vapor pressure will be high. Let's look at these ones in details. The strength of the intermolecular forces, that is the type of the functional group. We see that the melting point and boiling point increases, but the vapor pressure will reduce. So the intermolecular forces, as it increases, the boiling point and the melting point will increase. So if you look at this, because we're looking at the type of the functional group, each functional group has its own intermolecular forces of attraction it exerts. So if you look at this, these are just simple molecules which only have the induced or the temporary dipole forces. This one, they have the permanent ones because they have the oxygen or they have the halogens, which are a little bit more electronegative. So they pull the bonding pair of electron towards themselves. So they create what called a permanent dipole. So they create different charges on the molecule. And then these ones, because they have the hydrogen attached to oxygen, then it forms what called the weak hydrogen bonds. Weak hydrogen bonds are more stronger than the permanent dipole forces, and then the permanent dipole forces are more stronger than the induced ones. So as you go towards this side, then it means that the intermolecular forces of attraction is becoming more stronger. So increasing the intermolecular forces of attraction, it increases the boiling point and the melting point, and lowers the vapor pressure. So we have seen that London forces or induced forces are less powerful than dipole forces, which are permanent, and then are less stronger than the hydrogen bonds. Then here is an example. You have the same number of carbon atoms. What is changing is the functional group, because the functional group is changing, and as you continue, you have more weak hydrogen bonds. It changes from simple intermolecular force of attraction to more stronger. So it means that the melting point is going to increase, and also the boiling point is also going to increase. It may not matter the mass, as long as it is not of the same kind. Functional group will have a more say than the mass it has, because if you look at this, the mass is 30 and then this one, the mass, if you look at this, the mass is 64.5, and then this one is 48, but the 48 has a higher boiling point than the 6 because of the difference in the functional group. So this functional group is more stronger than this, so it creates the boiling point to be increasing, and then this one is also increasing while the vapor pressure is reducing. And then let's go to number 2. Number 2 is saying the number of the functional group, the number of the functional group of the same kind, of the same type. So here we have the same 1 2 3 1 2 3. So all of them, it has 3 carbon atoms, but what is changing is the number of functional group. The functional group is the same, is alcohol, 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 but here 2 3. If you look at the mass is in these molecules will be increasing a bit because of the number of atoms which are being added of the same functional group. So that creates more intermolecular forces, and also it creates more weak hydrogen bonds, or more hydrogen bonds. The hydrogen bond becomes more in here than this, and more in here than this. That's why you see here the boiling point is low, here is a little bit higher, and then this one is very high, and then because of increase in one functional group, so it almost doubles the boiling point, and then the vapor pressure also reduces. And then here, because we have tripled the functional group from the beginning, so it almost triples the boiling point, and then the vapor pressure has to reduce drastically. So that's why you're saying that the melting point and boiling point increases with increase of the same functional group, and the vapor pressure, obviously, we have to decrease, because we say that these two, they work in opposite way. Then number 3 is the relationship between the melting point, boiling point, and the vapor pressure of this is for a chain. So we are going to say that if you have the same kind of chain, is straight chain, but what is changing is the number of carbon atoms. Here, if you have 1 2 3 4, here you have 5, here you have 6. So what is happening? What is happening is the mass is increasing because you are adding more carbon atoms. Number 2, the temperature, the melting point and boiling point, they are increasing because the mass is increasing. Therefore, increasing mass of the molecules is the melting and the boiling point, and then the vapor pressure of those molecules must reduce because of the weak intermolecular forces of attraction, which are increasing as the molecule increases the mass or the number of carbon atoms. Then we are seeing here the size of contact area increases across which the intermolecular forces work. So as you increase, you are increasing the surface area, so that the contact area is increased. If the contact area is increased, it means that you are creating more intermolecular forces of attraction, which require more energy to break those intermolecular forces of attraction, so that it can turn into a boiling substance or a melting substance. Hence, the melting and boiling point increase while the vapor pressure has to decrease. Here you have a small chart or table trying to explain methane, ethane, propane, butane. So if you look at this, you'll find out that the melting point is increasing as you increase the number of carbon atoms. Number of carbon atoms are increasing. The boiling point is also increasing as you increase, but the vapor pressure is reducing until you reach a solid, because the solid, find out that it may not have, in this case, may not have vapor. Why? Because it is not, they don't sublime. So if they don't sublime, obviously you won't have pressure, vapor pressure for that kind. But if it sublimes like iodine, then automatically it will have vapor. So it will also have what you call the vapor pressure. So increase in the number of carbon atom increases the boiling point and melting point, or reduces the vapor pressure. Then the relationship between the melting point and boiling point, melting point, boiling point, and vapor pressure with the branched chain. So if you look at this one is a straight chain, and while this one is a branched chain. So this one has a larger contact area with the stronger forces of attraction. So it means that the area at which it exposes with one atom with the other is much greater, while here you only find out that the space is too small. The force of attraction will be weak. So that's why here you'll find out that it has a higher boiling point and melting point, while this one has a low boiling and melting point. But vapor pressure here is high and vapor pressure here is low. So here is an example. You find out that it's a straight chain, branch chain, more branched chain. If you look at it, you'll find out that they have the same mass. It means that the number of atoms are the same, but what is different is the arrangement of these atoms. Here, straight, branched, more branched. You find out that the boiling point is 36, 26, and then it's 9. So the more it's branched, the less the boiling point and the less the melting point. Why? Because of the contact area. The contact area of one molecule with another is too small compared to this, and then this one is a little bit higher. Therefore, this one requires more heat or more energy to break the intermolecular forces of attraction compared to this. Hence, the boiling point of this is higher than the boiling point of that. So thus we're saying that the more branches, the size of contact area over which the intermolecular forces work decrease. So the more it's branched, the size is decreasing, and then decreasing the strength of London forces or induced dipole forces. The boiling point decreases the more branches occur, and then the vapor pressure will increase as the boiling point and melting point increases. So the more branch you have, the higher the vapor pressure and the lower the melting and the boiling point. So basically that's it. And then let's look at some questions. You have a question. You have different molecules. What is different in these molecules? This one, they have the same number of carbon atom, but the arrangement of carbons are different. So when they give you a question, all the three factors must be kept constant. Only one must change. So you have to identify which factor is changing, and then be able to answer questions regarding to or based on that. Which compound A or C has the lowest boiling point? Give a reason for your answer. The one which has the lowest boiling point, it means that it must be more branched because it requires less heat to break the intermolecular forces of attraction. The contact area is small. So if you look at this one, it's more branched compared to this, and then this one is straight. So it while this one has a big contact force, a big contact area, so more intermolecular forces of attraction, more boiling point and more melting point, while it has low. So the answer is going to be lowest boiling point is going to be C. And then they're saying give the reason because of it's more branched, therefore the intermolecular forces of attraction is are weak, so it requires less heat or energy to break the forces between the molecules. Then which of A, B or C has the lowest vapor pressure at the same temperature? The lowest vapor pressure. The higher the vapor pressure, the lower the boiling point, and then the lower the melting point. So if the melting point is high, the vapor pressure must be low. So we have to look for the one which has the highest boiling point, and then if it is straight, has more melting and boiling points, and if it's branched, has less boiling and melting point. So in this case, it will have a higher boiling point and melting point, and then low vapor pressure. Remember those three, the two of them, they work together, and then the other one, they work in opposite way. So the answer is going to be A, because it is what it is straight, so it has more intermolecular forces of attraction which require more energy to break it, so that it can release it can make the atoms free, so that it can create the pressure. Is the boiling point of compound A higher than that of pentanal? Is A? What is A? Pentanal forms in intermolecular. It doesn't have weak hydrogen bonds because it doesn't have oxygen to hydrogen. Therefore, it means that it has permanent dipole forces, and then this one has weak hydrogen bonds. Therefore, it means that this one will have a higher boiling point compared to this. And then another question is you have to study it. You have P, Q, R and S, all this, and then they're saying that the vapor pressure are measured in millimeters of mercury. Atmospheric pressure is 700 millimeters of mercury. So you have these different graphs. with the vapor pressure here and then the boiling point here. What do they want from this? They're saying give a reason why alkanes are said to be saturated. Saturated compounds are compounds with a single bond throughout between the carbon atoms, and then unsaturated are compounds which have double bond somewhere between the carbon atoms. So in this case, because alkanes have single bonds throughout, therefore it is a saturated compound. And then define vapor pressure. We have defined it. Use the information in the graph above to answer the question. And they are saying what is the effect of increasing temperature on vapor pressure? So we saw that increasing the temperature reduces the vapor pressure. Yes, the higher the vapor pressure, the lower the temperature. The higher the temperature, the lower the vapor pressure. So increasing temperature, will it increase the vapor pressure? If you increase the temperature, will the vapor pressure increase? In this case, it means that you are heating at 100 degrees C, so you increase it to 200 degrees C. So that principle I've talked about does not apply in this case. So if you're heating at 100 and then you increase to 200, what will happen to the vapor pressure? So it means that you are making the bonds to be broken between the molecules, and then the atoms are being freed in the space, and then creates more vapor pressure. So it means that it will increase. So increasing the temperature of a substance will increase the vapor pressure. So it means that when you're doing an experiment, the temperature must be kept constant. Which compound has the boiling point of approximately 60 degrees C, and give a reason for your answer. So if you look at this is the temperature at which the substances boil. So you look at this one, it boils around 100, this one is around 80, and then you find out that you have this one which boils around 80, 68, around there, or 70. So it will be Q. They are saying give a reason for your answer. Yes, because its vapor pressure will equalize that of the atmosphere by this point. So it boils around that temperature. Which compound has the longest which compound has the longest chain length? Explain your answer. The longer the chain, the higher the boiling point, and the higher the melting point, and the lower the vapor pressure. If the chain is long, the vapor pressure must be low, and the boiling point and melting point must be high. So I'll come here and then check which one has the highest boiling point by looking at the temperature, and then which one has the lowest vapor pressure, which one has the highest boiling point, which one has the longest. Yes, so it means that it must have the highest boiling point. So if you come here, you'll find out that yes, you have this temperature is 100, and then what happens? 100, but the vapor is very low. So the higher the vapor pressure, the lower the boiling point. But this one, and then the higher the boiling point, the lower the vapor pressure. So we saw that this one, the longest chain, it must have a high boiling point and a low vapor pressure. So this one has 100, and then the vapor pressure is around 350. This one has 100, the vapor pressure is a little bit higher, and then this one, the vapor is high but the temperature is low. So it means that this one is going to qualify. Because why? Because the vapor pressure is low and the temperature is high. Therefore I will go to this. So the answer is going to be yes. Thank you very much for watching. Don't forget to subscribe for the new clips. We are going to be looking at fertilizers. Go and subscribe and hit the bell, the small bell there, so that you can get notification when new videos have been uploaded. Thank you very much. Welcome back to our class. Today we are going to be looking at physical sciences, paper 2, final exam 2023 MJ. All right, there are so many students who have just said that this paper was difficult, but we need to find out how difficult it was. Unfortunately, I may not have enough time to finish this because I'm not that well. But I'll try to push until I see that I've covered. But let me see if I can cover the first 5 questions. Then after that, I'll do another live when we are discussing this the last 4 questions. This is 2023 Physical Science Paper 2. That is what you call chemistry. Download the paper on Thundereduc or from Thundereduc. Let's go straight to the first question. The first question is talking about multiple questions, of which in most cases, multiple questions, they are supposed to be answered properly. Why am I saying that? Is because multiple questions are questions which you cannot leave when they're unanswered. So make sure that before you do anything, you have to get all the marks for multiple questions. Emo girl, I see you. Molly, I see you. Share the video so that people don't miss out. All right, let's go. For which one of the following molecular formulae are chain isomer? When you talk about a chain isomer, don't forget that we have 3 different types of isomers. So now, when you talk about chain isomer, we are looking at something which can change in the arrangement of the skeleton. For example, that compound must have more than 3 carbon atoms, because if it is 2, for example, 1, 2, there is no way how you're going to change it. If there are 3, 1, 2, 3, if you say that, okay, this one, we bring it here, and you form 1, 2, 3, still this is the same thing. Yes. So it must have more than, to form a chain isomer, you must have more than 3 carbon atoms, meaning that more than, starting from 4. So this one has 3, off, right answer. So this one becomes 2 marks there. Why am I saying that? Because if there are 4, 1, 2, 3, 4, that is the first isomer. So I can change it and I say 1, 2, 3, and then I put a carbon atom here. So it has changed the arrangement of carbon atoms on the straight chain. Hence, it becomes chain isomer. Question 1.2. I think I'm clear there. Question 1.2. Which one of the following compounds has the lowest vapor pressure? Look at this word, lowest vapor pressure. What does it mean? It means that when you talk about lowest vapor pressure, it means that highest boiling point. Don't forget that boiling point is inversely proportional to vapor pressure. So meaning that this boiling point, if it is too high, the vapor pressure is going to be low. So it means that we are supposed to look at these compounds, which one has the highest boiling point, so that I can get the lowest vapor pressure. But which factors cause these species to be having the lowest vapor pressure or the highest boiling point? You have to look at the forces of the intermolecular forces of attraction, London force, dipole, and then hydrogen bond. So you have to look at those ones. So, I can't find the 2023 paper on the website. Okay, we will send you a link concerning about that. Ne? Yes. All right. So we are saying that if you look at this, it means that 1, 2, 3, 4 carbon atoms. 4 carbon atoms these are 3 carbon atoms, these are 3 carbon atoms, these are 2 carbon atoms, but they have a unique character. This, however much these are 4, they only have London force because there is no hydrogen, there is no oxygen anywhere. So the oxygen is going to make it to have a higher boiling point or higher intermolecular forces of attraction. So it means that this is going to have London force from this side and hydrogen bond from that side. This one is going to have hydrogen bond from that side. It's going to have dipole, hydrogen, dipole, and the London force from that side. This one is going to have dipole, and London force. So it means that this one has a high number of intermolecular forces of attraction. Hence, it's going to have the highest boiling point. If it has the highest boiling point, it means that it's going to form low vapor pressure. Hence, the answer becomes D. So you get 2 marks there. 1.3. Is saying that just a moment. 1.3 is saying that the type of organic compound formed when haloalkane is heated in presence of concentrated solution of the base of base is an, what is it? Now, as long as there is no acid or there is no water in it, then the type of if it is haloalkane, the type of reaction which is going to take place is going to be elimination. What are you eliminating? You are eliminating this halogen. So the moment you eliminate halogen, you form a double bond. Hence, this one is going to be the most correct answer. So you get your 2 marks there. Then we are saying that excess hydrochloric acid, yes, look at this word, the word excess. It means that this is not going to be a limiting factor. The word excess is enough to take you off. But they're saying concentrated excess hydrochloric acid of concentration 0.1 molar or moles per decimeter cubed react with the 2 grams of magnesium under different conditions. Which one of the following combinations of conditions will produce the largest volume? So they are not talking about the fastest rate. They're talking about the largest volume. However, they're including this in the first minute, meaning that the fastest reaction. So because of that, saying that in this specific period of time, the first one, then automatically they are looking at the fastest reaction. So you look at the factors which factor affect the rate of reaction. In this case, we have temperature, and then we have how much the compound is divided. So granules are bigger than the powder. If they are powdered, it means that the chemical can reach on them more than here. An example, when you are eating, you break down the food so that the enzymes can reach that food more than when you have not chewed them. So if you chew the food, you are breaking it into smaller particles so that the reaction for you to become full is faster. Anyway, let's go. So they're saying that now anything which has powder is going to be faster. So this and this. So this is out. So always use elimination method to answer questions concerning about this. Elimination methods are the best. So now I know that this and this can't be the answer. So now I will look for which one has the highest temperature. So this is out. I get the correct answer. So C becomes the most correct answer. Let's go to 1.5. The diagram for chemical reaction is shown below. Okay, we are seeing the diagram. What are they saying? Which one of the following combination is correct for forward reaction? So now you have to understand here the concept that they are looking for forward reaction. If it is a forward reaction, and then this is the forward reaction, the one which goes here. They are not saying reverse reaction. So then we look at this. They're saying change in enthalpy change. Enthalpy change is final heat, yes, minus initial heat. All right, final is here, is X, and then this is initial. So it means that X minus Y. So anything which doesn't have X minus Y is out. Let's go. They are saying X minus Y, X minus Y, Y minus X, out. Y minus X, out. You see? So you're saying X minus Y. So now they're saying that, okay, so it means that either it is this or is this. Let's go to activation energy. Activation energy, when you go back here, activation energy is the energy from the beginning of the reactant to the highest part of the graph. So it means that here I'm gonna have from there to there. So that is going to be our activation energy. So if that is our activation energy, so it means that our activation energy is going to be, just a moment, technology. Technology is back now. Yes. They're saying that activation energy, they are saying that is from, is gonna be Z minus Y. Yes, so that's going to be the activation energy, Z minus Y. So we come here, we look for Z minus Y. So if we don't see Z minus Y, is out. So this is out, this is Z minus Y, this is out. But don't forget, this one is already out, and this one was already correct, but now it's out because of this. So it means that now the correct answer is this. I only have now one, because now this one was already out. So I only have C as the correct answer. Let's confirm and see if this is correct. They're saying that the potential energy the activated complex is having is this, from 0 to this, because they're saying potential energy at this point. So it means that answer is Z. So the most correct answer becomes C. I know that when the paper is not, you are not the one writing the paper looks to be easier. And if sometimes if someone is discussing it, you say, this paper was easy. But when you sit on that paper, you feel it hot. So don't just watch videos and think that the papers are always easy. Try to practice them. You will see that they're not easy, and you will need to practice as many questions as possible. Let's go to the next question. Consider the following reaction that reaches equilibrium in the beaker. You know, students are always having problems with reading these. Okay. The chromate is reacting with the hydrogen ion to form dichromate plus water. Few drops of concentrated sodium hydroxide are now added to the beaker. Which one of the following combinations correctly identifies the disturbance on the system, and the system responds to disturbance? Okay, here we come here and we look at this. What are we looking at? what do you add? You added the sodium hydroxide. When sodium hydroxide is ionized, it's going to form sodium ion plus hydroxyl ion. Yes. All right. So when you add the sodium ions or hydroxyl ions, yes, this is going to react with that to form H2O. Yes. When this reacts with that, automatically, what is going to happen is you are taking away this from the system. So automatically the system is supposed to react in such a way that it brings back what you have taken out. When you come and take my money, I have to fight and I see that my money is back. So I have to go to that direction of bringing back the situation to normal. In life science, we call it negative feedback mechanism. Here, we call it reinstates so that equilibrium is established. You understand? Yes. So if you're doing life science, we call it negative feedback mechanism. So the equilibrium is what we call homeostasis in terms of the system of the human. So in terms of the system of chemicals, we call it equilibrium. So I'm just bringing that if you're doing life science so that you understand better. Yes, you understand what? Better. All right. So it means that the reaction is going to be reversed. And the amount of this is going to reduce because it's going to react with this to form this. So we come here. Reversible reaction. This is out. This is out because we said reversible reaction is going to be favored. But the hydrogen ions is going to reduce. Let's see, this one decreases. This one's out. Then this one becomes the most correct answer. So the answer is going to be B, and you get your 2 marks. Let's go to question 1.7. According to Lorry-Brest theory, the conjugate base is formed when? Is formed when? Conjugate base is formed when? Okay, the proton is added to the acid. A proton can't be added to the acid because it's already acid. Don't forget that acid is a proton donor based on him, but based on this person is a proton donor, so it can't be added. So that is out. Then they're saying that electron is added to the acid. Electron is added to the acid. No. Don't forget that an acid is a substance which can release, which give out electrons, and that is based on Arrhenius. So out, because they are saying based on this. And then they're saying is added, so out. Proton is removed. Proton donor is removed, meaning that it donates. So the answer could be this. Electron is removed. This is not based on Lorry. This is based on Arrhenius. So the correct answer becomes that. Hence, yeah. I think the paper was not that bad in terms of the objectives, because we don't know yet what's going to happen afterwards on the other questions. Consider the statement below regarding to the alkaline substance. Alkaline substance, yes, react with the alkaline. Don't forget that the pH is above 7. So react with the acid to form definitely base. This base, when react with the an acid, you form a neutral solution. Yes. However, the solution can be a little bit of, yes, the end point could be a little bit up, down, depending on which is a strong base or strong acid or weak base, whatever. All right. We will explain that when you go to acids and bases. So we are saying that it turns litmus paper blue, alkaline, cool. Forms salt when it reacts with an acid. Yes, you have that principle that base plus acid, you form salt plus water. Yes. So meaning that it forms a salt when it reacts with the acid. Cool. So it is also correct. So we consider the solution of sodium chloride brine. Concentrated solution. Wait, they're saying concentrated solution. So if they're talking about a concentrated solution, is different from molten molten sodium chloride. If they are talking about solution, it means that it has some water there. It means that the water molecules are going to be a little bit high compared to, yes, okay, let's go. Undergoes electrolysis. Which one of the following combination correctly shows the product formed at each electrode? Don't forget that this is the electrolysis electrochemical cell, meaning that this one becomes negative while this one becomes positive. So the positively charged ions, they will go to this, and the negatively charged ions will go here. So let's see. Sodium, yes, but will not be discharged. Why? Because you have sodium there and you have the hydrogen there. So sodium won't be discharged, this will be discharged. Cool. So this one goes out. This side, okay, so this one is out. Hydrogen, yes, hydrogen is discharged, yes, is correct. But let's look at this side. This is the anode. Sorry, anode, which is a positive. Positive, you will have, yes, you will have the chloride, and you will have that. So, but now this one is going to be released easier than this. Yes. So it means that this one is out. So now even this one is out. Oh my God. All right. Let's see. Chlorine will be released. We have said that this one will go to the positive. So this is out. What's the correct answer? We have got it. Say that chloride is gonna be there, and then it's gonna release the electron and then combine with another one, then form chlorine gas. And then here the water will split. When the water splits, what happens? You're gonna form hydrogen ion plus OH. Yes, here. And then this one is gonna be discharged as hydrogen gas. So meaning that this reaction is gonna take place here. And then the most correct answer becomes D. Yeah, that is the first question. How many marks? 20 marks. Mahala. 20 marks? Mahala. Sir, are you going to do business paper 1? The business teacher will do it. Yes, because I'm purely science teacher. Yes, but the business gift, Masana. Yes, the teacher for business is gonna do it. Yes, is gonna do it immediately after, hopefully in most cases a day after you have written, or immediately after you have written. Yeah, so but he's gonna do the business paper. Anyway, let's go. Study the table below and answer the question that follows. Yes, you have this structure. This structure is showing you, okay, 1, 2, 3, 4. Okay, this is a hydrocarbon. Let's go to the questions and define the term unsaturated. Unsaturated, it means that you don't have a double bond. No. Yes, you don't have a double bond between carbon atoms, between two carbon atoms. You don't have a triple bond. That it means that it is saturated. Yes, it means that it is saturated. So if it is saturated, it means that I have 1, 2, 3, for example. That is saturated. But if it's unsaturated, you have 1. I have a double bond somewhere, or I have a triple bond somewhere. So what is define the term saturated? Hydrocarbon is a hydrocarbon, a compound which is made up of hydrogen and carbon only, with double or triple bond between the carbon atom. Or is a compound which has a double or a triple bond between two carbon atoms. Simple. We go to write down letters that represent they're saying that letters that represent unsaturated compound. If you come here, you look at unsaturated compound, desaturated compound, unsaturated. This one is saturated because all single bond throughout, single bond throughout, single bond throughout. This one is also single bond. What about this one now? This, and this. There is a double bond here. Look at this. So if we say 1, yes, 2, 3, 4, 5. 1, 2, 3, 4. They compressed it here. But now if you look at this one is saying CH and then CH2. I'm magnifying it so that you can see. This carbon has only one hydrogen, and this one has 2 carbon. It's supposed to have 3 if it has a single bond throughout. So it means that it's going to be 1, 2. So basically it's going to be C, 1 carbon, and a double bond, yes, another hydrogen, and another hydrogen, and then here you form this species. You see? So it means that that is the species you're gonna form, of which is gonna be 1, 2, 3, 4. Correct. 1, 2, 3, 4. Correct. You see, there is a double bond there. So D becomes the structure which you're supposed to talk about here. IPAC name of compound A. What is compound A now? Compound A here is 1. So now you have to find the longest chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. If I make this the longest chain, this one. Yeah. If I make that one the longest chain, what's going to happen? So it means that this and this are going to be side chains. So let's find, count 1, 2, 3, 4, 5, 6. So it's going to be hexane. But now I have hexane is the first branch is on carbon atom number 1. The second branch is on carbon atom number 1, 2, 3. Is on carbon atom number 2. First branch is on carbon atom number 2 because 1, 2. Yes, this branch on carbon atom number 2. 1, 2, 3, 4. Carbon atom number 4. If I count from this side, 1, 2, 3, no. So I have to go with the 2. So it's gonna be 2. It's a methyl, and also this is a methyl. Therefore, I'm gonna say 2, 4 dimethyl hexane. Is it correct? You're gonna say yes. No, it's not yet correct. Why? 2 is a figure and a figure by a comma, but a figure and a word is by dash. So 2, 4 dash dimethyl hexane. Now it's correct. So that is how you're supposed to write it. IPAC name of compound A, we are done with that. IPAC name of position isomer of B. Where's B now? Okay, this is an alcohol. 1, 2, 3. Yes. So when you talk about position isomer, you see now, yeah, it can't be a structural isomer. It can only be positional isomer. It can't be structural isomer. Why? Because it's not more than 3 carbon atoms. It only has 3 carbon atoms. So if it's 1, 2, 3, and then alcohol here, so it means that what you're gonna do is just to change this primary alcohol into a secondary alcohol, then you have formed an isomer. How do you do that? Change this, bring it there. Bring this hydrogen this side. 1, 2, 3. Bring alcohol here, and then the rest of the hydrogen. The structure is done. Simple. Then we go to the next question. IPAC name of IPAC name of compound D. Where is compound D? Is this one which we talked about. So is 3 is 1 plus 4, then a 2. So I'm gonna have, it said is 1 CH3, and then these ones are 4 of them. 1, 2, 3, 4, and then a double bond there. So it's like that. If you look at it here, let me just clear here so that you understand it. 4 of them plus this, that's 5, 6, 7. So meaning that C is gonna be hep 10, but it has a double bond, so it is gonna be in. So hept in. But what's the position of this double bond is on carbon atom number 1, so it's gonna be hept 1 in. Simple. Hept 1 in. So you get the marks. How many marks are there? 2 marks. Mahala. Let's go to question. Question. Which balanced equation of sorry, technology. So all right, so they're saying that identify the balanced equation of the molecular formula for complete combustion of A. How do I go about that? So you come here, let's write here in this space, saying that the balanced equation of complete combustion of A. Let's go to combustion of A. Where is A? Oh, is this one. So let me clear it so that I can count the hydrogen properly. Yes. Okay, how many carbon atoms are there? We say that is 1, is 2, is 3, is 4, is 5, is 6, 7, 8. So when I say here, carbon is 8. But this is an alkane. Don't forget that when you're saying that it's an alkane, it has this formula. You can count the number of hydrogen direct, but if you don't want, you can still use this. Since N is 8, automatically it's going to be 8 times 2 plus 2. This is 10 plus 2, which is 12. So carbon is going to be 8. Hydrogen is going to be 12. Yes. But they're saying combustion, which means oxygen. Wabona. Then you react with this. Always when you talk about hydrocarbon burning, we only produce one product. That is carbon dioxide plus H2O. So this is a liquid, this is a gas, this is a gas, this is a gas. This can also be a gaseous form because it is hot. It's hot. So you won't be able to see water there. You just have to see steam. Yeah, steaming. Yeah, steaming. All right. The most complicated thing here is balancing the equation. And this has been a problem for students from grade when they get to know what is called chemistry until they finish their university. Yeah. Anyway, let's try to balance. Carbon, how many carbons do I have? 8. This side I have 1. So I'm gonna have put 8 here. Cool. If I put 8 there, what's next? So if I put 8 here, hydrogen 12. Hydrogen here I have 12. Here I have 6. I have 12. I have to put 6, so it's gonna be 12. Now the most complicated answer here, the most complicated problem here is the oxygen. The moment oxygen is not balanced, everything you have to do them again. Okay, 6 plus 8. 6 plus 8. Wait, something is not right here. Something is not right here. You know why? Yes, I'm just seeing it here. That I didn't add here. I said this is 10 is 10 plus 2, which is 12. It's not supposed to be 12. 12. plus this 8. Is it? Yes. Is 8. 8 it's 16, eh? 16. It's not 10. This is not addition. It's multiplication. Is 16 plus 2, which makes it 18. So this is 18, not 8. All right. Now we have to balance. You have to rebalance here. So it means that you have 18 here. Here carbon. If I put here 18, it's too much, ne? I have carbon. What's happening now? It's not carbon. This is 8. Hydrogen is down, which is 18. Hydrogen is 18. Eh? Ask is, all right, hydrogen is 18. Carbon is 8, cool. Hydrogen is 18. So what am I doing here? What am I putting here? If I put 9 here, the moment you bring 9 here, this oxygen won't be able to balance. Anyway, let's continue and we see. So now you have oxygen here is 9 plus 8. How much is that? 9. But this 8 is times 2. So it is 16 plus 9, which gives me 25. This side I have how much? See, if I put a 12 here, it's going to be 24. 1 is short. So what am I supposed to do? Let me increase. Let me put a 2 here. Yes. So I have 16 carbon. And then now I have increased the hydrogen. So hydrogen is going to become 18 times 2, which gives me 36. Okay. Now, if I have 36 carbon, hydrogen, how much do I have this side? So what am I going to do? I'm going to increase this to 18. So that is 36. So if I have 36 here, I'm going to have, yes, 18 oxygen here. Now, how much I'm supposed to put here? Because now this carbon is 16 now. You see, it's 16, but here I only have 8. So I have to increase this to 16. Yes, that's what you call balancing. 16. Yes. Let's see. 16. Yes, 16. So now it means that here I have 18 oxygen. 16 times 2 is 32. 32, yes, plus this 18. So is 18. This is 0. This is 5. So it gives me 50. So now, if that is 50, then how do I make this oxygen 50? So I'm going to make this oxygen 50 by putting a 25. I think it's balanced. Ne? Yeah, ne? Yeah. So now let's go back and see how this is balanced. I know that balancing is a problem to everybody. Yes, everybody. Yeah, who is writing a paper. Why? Because you are rushing. So that is 2. We say that is 2. So we say that this is 25. Yes, we say this is 25. 25. And then we say this is 16. And then we say this is, let me remove this one. This is 18. Yes. Yes, I think it's balanced. This is 16. And then this is 50. And then this carbon, this is 36. Hydrogen is 36. So I must have the same order. Carbon is 16, you see. 16. So this one is correct. And then oxygen, let me go to hydrogen first. Hydrogen is 36, you see. 18 times 2 is 36. 36, so correct. I have to look for 50. If I don't get 50, then I have to change until I get them balanced. Okay, 16. Yes, this is 16 times 2 is 32 plus 18 here. Yeah, it gives me 50. So it means that it's balanced. So you see, I always advise my students that when you write these equations, make sure that you write. If you see that the balancing is a problem, first leave it, continue, and then you come back and see if you can balance it. Ne? See if you can do what? You can balance it. If you see that you can't balance it, ne? Then balance when you are done answering other questions, or otherwise you're going to spend a lot of time just for 1 mark, and then you could have got other marks somewhere else. Yes, so basically that's how you supposed to write that equation. Yeah, I think now I see that. Yeah, someone said that this paper was difficult. Yeah, maybe found that question and then killed him. All right, let's go. Formula. This represent two compounds that are functional isomer of each other. All right, what is a functional isomer? A functional isomer is a molecule which has the same molecular formula but different. Remember, functional. What is different is the functional. Structure, what is different is the structure. Ne? You see? Position, what is different? Position isomer, what is different is the position of the functional group. So here, the functional isomer, what is different is the functional group. Molecules with the same molecular formula but different functional group. Example, we can talk about aldehyde and ketones, esters and carboxylic acids, alcohols and ethers, but we don't teach ethers here. Ne? Yes, so all those are functional isomers. So they're saying write down the structure formula of each of the functional isomers. Hey, now from where? Oh, here. So they're saying that C480, C4H80. So functional isomer 1, 2, 3, 4. So I put hydrogens. Let me make sure that each bond has four bonds, each carbon atom. Hydrogen, hydrogen, hydrogen. That is 3. Ne? So 3 gone. Hydrogen, hydrogen, so plus 2. So that is 5. Hydrogen, hydrogen, plus 2. That is 7. Meaning that I am remaining with 1. Oh. So if I'm remaining with 1, I put oxygen, I put the hydrogen there, so that I have 8 hydrogens. So it means that this is an aldehyde. So it means that if I'm going to write the functional isomer, I'm just going to write the keton. Simple. Just change this, put it there. I've got the marks. 1, 2, 3, 4. Put it there. Either here or here is the same thing. When you are doing the nomenclature or naming, it's going to be the same thing. Don't forget that these things you're supposed to put hydrogens, but for the case of time, so that's why I just put dash, dash, dash. Ne? Yes. So that is it. I get it there. And then the next question. What is the next question? The next question, they are saying that oh, is a calculation. 2 grams of, just a moment, 2 grams of sample. Yes. Yes. Switch. Good. All right. 2 grams of E contains 1.09 grams of carbon and 0.8 grams of hydrogen. The molecular mass of the compound E is 88 grams. Ne? Okay, determine the molecular formula of compound E by means of calculation. Okay, so here what you need to do is to find the first structure. And to find the first structure, you have to draw which elements do we have here. We have carbon, hydrogen, and oxygen. Because they're saying the molecular formula of this compound E, and if you look at this compound E, it looks like this. X, C, H, O. So it means that I have C, X, H, Y, or Z. Meaning that these are numbers. These are numbers. So what do you do is to find out. So these are the elements I have. I need to know the mass they have. Mass, if you go here, they say that, what did they say about carbon? they said that carbon is 1.09, and then hydrogen is 0.18, if I'm not mistaken, 0.18. And then what about oxygen? But they said a sample of E contains 2 grams. So it means that if I add this and this, when I subtract, I must get the balance of E. So this plus this, you're gonna get 1.7. Yes, you must get 1. Let me just get a calculator. Calculator is here. Let me add and then I see. So is 109 plus 0.18. Answer is 1.27. 1.27 minus 2 minus 1.27, the answer, so it's minus 2, answer is 0.73. So it means that oxygen is 0.73. So what is the atomic mass of carbon? You find this in the periodic table. The atomic mass of carbon is gonna be 12. Hydrogen is 1 and oxygen is 16. Yeah, so that is the atomic mass of that. So if that is the atomic mass, so it means that I'm going to say I'm going to find out the number of moles. Number of moles is obtained by mass over atomic mass. So I'm going to say 1.09 divided by 12. Answer is 0.09. And then obviously this one's going to be 0.18 because they divide by 1. And then 0.73 divided by 16. Answer is going to be 0.046. Yes, so I divide by the simplest so that I can find the ratio. Ratio. So I'm going to divide by the simplest. Which one is the smallest? Is this one. So I'm going to say divide by the same answer. I'm going to get 1, meaning divide by 0.46, divided by 0.046, divided by 0.046. So I'm going to have 1 here. What about here? I'm going to say 0.18 divided by that answer. So it's going to be 0.39, approximately 4. And then what about here? 0.09 divided by 0.04. 46. Answer is 1.95. You can calculate and see, just in case I miscalculate. Okay, so it's gonna be the answer is going to be 2, approximately 2. So now that's not the answer. The answer is gonna be C is gonna be 2, H is gonna be 4, and O is gonna be 1. But they say that the molecular mass of the whole molecule is 88. So it means that I have to introduce here the number of moles and equate them to 88. So remember we said that hydrogen is 12, yes, times 2 plus 1 is carbon is 12, hydrogen is 1 times 4, and then oxygen is oxygen is 1 times 16. So when you add here is 14, is 4, yeah, this one is 16, so this one goes here 20, yeah, 20, 30, yeah, 44, meaning that 44, all this is n, so 44n is equal to 88. So divided by 44, divided by 44, 44 here, so n is equal to 2. That's not the answer. So the final answer is gonna be, therefore, remember n is equal to 2. So if I have C2H4O, and then we are saying that n and n is equal to 2, then automatically I'm gonna have this structure which is C. This C is times 2, so it's gonna be 4, H is times 2, it's going to be 8, and then oxygen is going to be 1 times 2, which is that. So this is the answer they are looking for. So when they say determine the molecular formula of the compound E, so basically that is it. Question. Let's go to the next question. The next question is saying, if you have a question, yeah, let me know, let me know. Gift, if you have a question, let me know, yeah, so that I can smash it before I go to the next question. All right. Question 3. They're saying that learners investigated the boiling point of 4 organic compounds given below. Okay. You have the first compound is butanone. You need to first analyze this. The good thing is these ones, they have the same molecular mass. What about these ones? Sorry, they don't have the same, but this one is an alcohol, this is an alcohol, this is a carboxylic acid, this is a ketone. Now, okay, that's fine. Define the boiling point. Boiling point is the point at which the vapor pressure of that liquid is equal to the atmospheric pressure. So it's a point. Don't say that is when, don't just say that boiling point is when. The boiling point of when is the point at which the vapor pressure of that liquid is equal to the atmospheric pressure. That's when the boiling. There is a difference between a boiling point and boiling. Ne? Yes. So if the question comes and is asking boiling, define boiling. If the question is asking boiling point, so make sure that you define boiling point. So the question is saying which compound butan 1-ol or 2-methyl propane will have the highest boiling point. Here you look at these two. When you're saying that butan 1-ol is this. This and this, these two are isomers. Ne? Yes, the isomers. And this one has a straight chain while this one has a branched chain. Based on the factors which affect the boiling point, melting point, vapor pressure, to find out that the one which is straight is going to have a higher boiling point and a low vapor pressure because of the stronger intermolecular forces of attraction, as long as the mass is the same. So this one is going to have a higher intermolecular forces of attraction, which will require more heat to be broken down, hence a higher boiling point. Why? Because the molecules are packed. Therefore, there is strong intermolecular forces of attraction compared to the one which is branched. Hence, butan 1-ol is going to have a higher boiling point than 2-methyl propane 1-ol. Let's go to question. The next question. P, Q, R, and S below were obtained from results of investigation. X represents specific temperature. Okay. X represents specific temperature. They're saying that the first question, which physical property is represented by temperature X? That's boiling. Because they're talking about boiling, heating, boiling. So now, they're asking you, which graph P, Q, R, and S represents butanone, propanoic acid, 2-methyl propane 1. So here, you have to know which one has the highest, the strongest intermolecular forces of attraction. If you look at this one will have London force and dipole. This one will have London force and hydrogen bond. This one is going to have London force, hydrogen bond, and dipole. This one is going to have London force and hydrogen. But this one is a branched, but this one is straight. So this one is going to be number 1 in the temperature, highest, followed by, don't forget that hydrogen bond is stronger than London force. So this one than London force, and also stronger than dipole. So the butan 1-ol is going to be number 2 in the temperature, and then it's going to be 3, and then it's going to be 4. So let's go and find out. Let's go and find out which P, Q, R, and S butanone. Okay. is butanon. Butanon is going to be number 4. So the one which has the lowest boiling point. So it's going to be S. So the answer is going to be S. Propanoic acid has the highest. It must be number 1. Highest boiling point. Highest is P. So it's going to be P. And then 2-methylpropan-1-ol. 2-methylpropan-1-ol is going to be 3, number 3, based on this. So it's going to be 1, 2, 3. It's going to be Q. So yeah, that's it. The next question they're asking, give a reason for your answer for this one. For P, why propanoic acid is having a highest boiling point? We say that it has the strongest intermolecular forces of attraction. That is the London force, hydrogen bond, and dipole. It has all the three. Intermolecular forces of attraction. Yes, let's go to the next question, which is the next organic molecule. Question 4. Okay, question 4, what are they saying? Question number 4, they're saying, the following diagram below shows the different organic reactions. Okay. It's showing the different organic reactions. PQR and the PQR are organic compounds. Okay. Reaction 1, 2, 3, and 4. Okay, sharp. Reaction 1. It means that my focus must be on reaction 1. The type of additional reaction. Okay, reaction 1 is here. But what if it is this? If this is addition, it means that this was having a double bond somewhere. And what are you adding? You are adding the bromo to bromo. It means that you're adding this bromine. Oh, they have even showed it here. You're adding the bromine. So it's gonna be bromination. Yes, you get your mark. Observable change which occurs in the container during the reaction. Guys, this reaction is very important in confirming. Whether the compound is saturated or unsaturated. If the compound is saturated, then it means that it's going to have to decarboxylize. If the compound is unsaturated, is having a double bond somewhere, is going to decarboxylize the bromine water. Don't forget that the bromine water is red in color. So the red color is going to disappear. So what you see here, you're going to see the decarboxylation of bromine water, or the red color is disappearing. Yes. So the structure formula of compound Q is Q. Okay, say that he has a double bond. But now look, how many carbon atoms are there? I need to know. Look here, they are saying that propan, but methyl. So it has propan is 3. So 1, 2, 3. But it has a methyl, meaning that it has another carbon atom there. Yes. But don't forget that it was a double bond. It has a double bond here. It was unsaturated, so it means that this bond will go. And then now I'm gonna have another bond here. You see? So that now 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Yeah. 1, 2, 3, 4. Yeah. So the reaction is gonna be like this. But don't forget to put hydrogens everywhere. Yes. Then you're saying write down the APAC name. Consider reaction 2. What's the reaction 2? Where is reaction 2? Reaction 2 is from the same molecule, but I'm adding hydrogen chloride. If I'm adding hydrogen chloride, write down the APAC name of compound R. What is compound R? Compound R is here, the major product. So if it is a major product, it's going to follow what's called the Markovnikov rule. Yes. The richer must get richer. The rich must get richer, and the poor must become poorer. That's Markovnikov rule. If you have more hydrogen, the carbon atom with the more hydrogen will take the hydrogen, and the carbon atom without hydrogen will take the halogen. So the structure was like this. Let me see. Saying this. Okay, sharp. So remember, it was like this. Yes, it was like this. Okay, this one has a hydrogen and a hydrogen. So it has 2 hydrogen, while this one has nothing. So it's like this. So I want to add hydrogen chloride or hydrochloric acid, whatever. Look. So now this hydrogen is gonna go to the richer, and then this one is gonna go to the poorer. The poor person, the poor atom. So now it becomes, this one is gonna be C. Now it's gonna have 3 hydrogen. With the double bond is gonna break. I'm gonna have a chloride here, and then I'm gonna have the methyl down, and then I'm gonna have this here. I'm gonna have this here. So that's the structure they are looking at. Don't forget to put the hydrogen. This is a chloride. Yes. So basically that is it. Reaction 3, a balanced equation using structure formula for the organic compound. Reaction 3. Let's go to reaction 3 and see. So from there to alcohol. So here I have to add some bit of OH. So how am I going to add that OH? It means that I have to add dilute acid, acidified water, basically. So I'm gonna have, did I say structure formula? Let me check. Did I say structure formula? Yes. So it's gonna be 1, 2, 3. Yes. Don't forget the hydrogens. So, and then now I'm gonna have, so don't forget to acidify it, so that I have the OH in abundance, so that it replaces that. So it's gonna have, yes, so this, but don't forget that this is chloride. So the chloride is going to be replaced by OH, and the moment you form the OH there, automatically that becomes an alcohol. Hence the structure is done. You have to put the hydrogens there. Guys, if you don't put those hydrogen, you will get 0. You see those 6 marks they're talking about? You will get 0. So make sure that you draw your structures properly, 100%. Alpha name of compound of alcohol, P. Where is alcohol, P? Oh, the alcohol we have formed here. So it's gonna be 1, 2, 3, 4. Okay, it's gonna be 3. It's gonna be pan, but it's on carbon. This one is on carbon atom number 2, 2 or, but it has a side group. Side group is on carbon atom number 2, so it's 2 methyl, because the side group has 1 carbon atom. 2 methyl propan 2 or. Hence, that's the answer. Then we got to the next question. So this is done, and this is done. Reaction 4. I know that synthesis sometimes is a problem to students. We call this synthesis. Synthesis sometimes is a problem to the students. So if I'm explaining something and you don't understand it, please let me know. Yeah, let me know before. Yeah. All right. Reaction 4 is elimination reaction. Write down the type of elimination reaction. Where is it? Reaction 4. You're from alcohol to this one. What are you eliminating? You're eliminating water. So it means that you change the alcohol to alkene. So the elimination reaction there is going to be dehydration. Dehydration, because you are removing the water molecule there. You are removing the OH from there. OH. The type of reaction that takes place. Okay. Butane 1-ol reacts with propanoic acid. When you say butane 1-ol, that's an alcohol, reacts with the carboxylic acid to form in presence of a catalyst. Write down. The moment an alcohol with a carboxylic acid reacts in presence of a catalyst, and this one is sulfuric acid, and it must be conc in presence of heat. Yes, then it's going to be esterification. So this answer is esterification. Sometimes you can call it condensation. Yes. But now, butane 1-ol, propanoic acid. Butane 1-ol. Butane 1-ol. 1, 2, 1, 2, 3. Butane, 3, 4. It's saying 1-ol. Then propanoic acid, 1, 2, 3. Then, oh, yes. So meaning that this one is going to be lost, and then this one is going to be lost. You form water. That's why you call it condensation. Yes. Now, after that, don't forget that these ones you're supposed to put the hydrogens. The hydrogens. If you don't put the hydrogens, you're going to get it 0. 0. And we love to give a 0 than a tick. So if you are just negligent on your work, you will score a 0 with eyes. Big eyes. Sorry if you have big eyes. So what happens here is going to be 1, 2, 3, 4. Yes, you have this oxygen there. Yes, but the oxygen now is going to combine with this carbon. So you form that carbon. This oxygen is going to go up, and then you form another carbon here, and then another carbon. Basically, that is it. 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 So now, question: how do you name this? Because this is coming from alcohol, then it's going to become 1, 2, 3, 4. It's going to become butyl. And then this one, 1, 2, 3, it's going to become propanoate. Butyl propanoate. That's it. That's it. You get your 2 marks. Question 5. Question 5, I said that I'm going to go up to question 5. Then I'll get another time, and then I shoot from question 6, 7, 8, and 9. Yes. So let's go to question number 5. Question number 5. Welcome to question number 5. Are you there? All right, let's go. Saying that, consider the following decomposition reaction that takes place in a sealed 2 decimeter cubed container. All right. So what is happening there? We are saying that here you have dinitrogen tetraoxide. Yeah, I told you that this is a problem with the students. They don't know how to say these chemical names. Dinitrogen tetraoxide reacts with it decomposes to form nitrogen dioxide plus oxygen. The graph below shows the concentration of dinitrogen tetraoxide and the nitrogen dioxide. Okay, sharp. Let's go. It changes to the time. All right. So which one is dinitrogen tetraoxide? Because this is dinitrogen tetraoxide is a reactant, therefore is supposed to be going down, meaning that this is dinitrogen tetraoxide, and then this is nitrogen dioxide. Okay, because this is a product, and the product is always increasing, and in most cases the products, they start from 0 and then they go up. Refer to the graph above. Give a reason why A represents a change in the concentration of nitrogen dioxide. Nitrogen dioxide, A. Why are you saying that A? Why are you saying that A? Where is A? All right. Why are you saying that is A, which is this? It's because we are saying that it's because A, where is it? Yeah, it's because its concentration is increasing, and here nitrogen dioxide is a product. The concentration of A is increasing because it is a what? Is a product. Yes. Consider the statement below. The rate of decomposition of dinitrogen tetraoxide is half the rate of formation of this. If I have is half the rate of formation of this, meaning that nitrogen tetraoxide, the rate, if I have 1 here, then here nitrogen dioxide, the rate of decomposition of this is half the rate of formation of this, meaning that if this one must be half the rate of decomposition of nitrogen tetroxide is half the rate of formation of this. Now here you have to come back here to the mole ratio and see the rate of decomposition of this is half of this. Is it true? Is this half of this? You come back here, meaning that if here I have half, yes, here I have 1. The rate of decomposition of this, yes, is half the rate of formation of this, meaning that if this one is 1, this one is half. Half of this is this. Let's go. Is half of this, half of this one is 4, is half of 4 equals to this? Is half of 4 equals to 2? Yes. So the answer is yes. Is the statement true? Yes. Give a reason for your answer. Why? Is because 2 moles of nitrogen tetroxide produce 4 moles of nitrogen dioxide. Yes, that's it. Calculate. Oh, you're going for calculation. Calculation time. Mass of nitrogen dioxide present in the container at the 40 minutes, 400 minutes, seconds, not minutes. So if you look at this, you come here on 400 is here. Ne? Yes. But they are saying they are looking for the mass. Ne? Are they looking for the mass? What are they saying here? What are they saying here? Mass of nitrogen dioxide present. So how am I going to find the mass? Yes, we have 2 formulas, but let's first find out what do we have so that we can use the mass. We can calculate with the mass. Okay, first of all, I have at 400 seconds. What do I have here? Here I have concentration. Ne? So the mass is going to be, concentration is 200. Ne? It's 200. It's 200, but it's not 200. Yes, it's not 200. Look at this versus this. So the answer is going to be here. The concentration here is going to be, the concentration here is going to be, okay, let me just do like this. Okay? What is the question? Mass of nitrogen dioxide, okay, present. Okay, let me use this space. They are looking for mass at 400 seconds. But if you are saying 400 seconds, let's come back here. They're looking for mass of nitrogen dioxide. Ne? They're looking for mass of nitrogen dioxide. Let's write it here. We are looking for mass of nitrogen dioxide. But now, let's look at it here. The concentration, what's the concentration? Concentration is equal to, we have said is 200. But look here, times 10 power negative 4 times 10 power negative 4. So that is the concentration. And then now it means that it is 2.0 times 10 power negative 2 molar or moles per decimeter cubed. But now we are looking for mass. So it means that, do we have the volume? Don't forget that mass or number of moles is equal to mass over molar mass. Okay. Number of moles is equal to mass over molar mass. Do I have number of volume, number of moles? No. Do I have molar mass? I can calculate it. Do I have mass? No. So, but I can calculate the number of moles. Number of moles is equal to, yes, is equal to concentration over volume. But this must be a molar volume in decimeter cubed. So it means that number of moles is equal to concentration, which is 2.0 times 10 power negative 2, divided by the volume. What is the volume? What was the volume? Let's go back. And they said what? Yeah, they said a 2 decimeter cubed. So it means that I'm going to divide it with 2. So divide by 2. So the answer I get is going to be the number of moles. It's going to be the number of moles. So the number of moles is going to be, let me use the calculator and see, 2 times exponent negative 2, yes, times, not times, divided by 2, answer. The answer is going to be 0.01. So the answer here is going to be 0.01 moles. Yes. So now I've got the moles. I've got the number of moles. Yes. So since I have the number of moles, I can have the mass now. But do I have the molar mass? I can find nitrogen dioxide is equal to nitrogen is 14 plus oxygen is 16 times 2. So this is 32 plus 14 plus 14. This is 6, and then this is 4, meaning that is 46. Yeah, 46. So it means that I'm gonna come here and say that number of moles is equal to mass over molar mass, of which number of moles is 0.01 is equal to mass over molar mass. The molar mass is 46. So the number of mass is equal to 0.01 times 46. So mass is equal to dash grams. So 0. Times 46. Answer is going to be, the mass is going to be 0.46 grams. Yes, that is the mass at this specific point. That is the mass at this specific point, which was remaining. Yes, that's the correct answer. Sometimes when we are pressing the calculator, sometimes you end up missing a figure. So you can recalculate, but that's the steps you are supposed to follow when you are doing that calculation. Then average rate of production of oxygen. When we talk about average rate of production of oxygen, then we come here. Let's see, average rate of production of oxygen. Where is it now? Average rate of production of oxygen. Where is oxygen? Oh, yeah. But now we don't have oxygen here. Do we have oxygen here? We don't have oxygen here. But now we can use the rate of production of oxygen. How do we identify this? So we can find the rate of
They said the writing cut tomorrow. What they're writing tomorrow was sent to the group, but I did not see in the group under 12. Sorry.
So we are saying that so what we are saying that let's go to the next question and we see. So we are saying that we are calculating. Okay, if you have a question, guys, let me know. Let me know. So we are saying that, yes, the average rate of production of oxygen at they're saying in, meaning that from 0 to 700. But now rate, you're supposed to use what we call the rate of reaction expression, meaning that you're gonna say change in the concentration, but here we can use this. Let me show you. We can use this. If you use this, after that we can use it to mole ratio to find out the rate, because the rate of this formation, yes, this one is 4 times the rate of formation of this. You understand? 4 moles of nitrogen dioxide. When you form 4 moles, you form 1 mole of oxygen. That's the meaning. So now let's come here. Let's come here and then we start calculating. Okay, rate is equal to final concentration minus initial concentration over final time over change in time, that is initial, of which initial time, final time here based on this is going to be, because they said in the first 700 seconds, so it means that it's going to be 700, final is going to be 700 in the first, meaning that minus 0, and then here is going to be, you have to calculate and see each box is what, each box is 20, ne? Each box must be 20, 30. Yes, so it means that this is 250 plus 30, giving me, let me see if this is 1 2 3 4 5 6 7 8 9 10. Yes, ne? Yeah, so it's 10, ne? So if it's 10, this is 250 to this, so it means that each, so it means that this is 10, so it means that each box is 5, not 10, is 5, So now they're saying 700 is here, 700 is here. So how many boxes are 5, 10, 15, 20, 25, 30. So 30 plus this 250, so it means that is 280. Yes, so it means that my concentration is gonna be 280 minus 0. So I'm gonna have 280 divided by 700, so it gives me the answer to be 0.4 moles. Yeah, if it is 0.4 moles, but now don't forget that we saw here that what what they are looking for here is oxygen. Where is it? What they are looking for here is oxygen, and what we have calculated is nitrogen dioxide. So I'm going to have divide, so it's gonna be 4 to 1. So it's gonna be let me check here. Let me check something here, because they say that the graph shows the concentration of nitrogen dinitrogen tetraoxide and the nitrogen oxide, dinitrogen tetraoxide and nitrogen dioxide. So they didn't say that this graph is oxygen, so that's why we have to bring in, and then we say that if 4 moles of this is 0.4, then 1 mole is going to be what? X, and then cross multiply, so meaning that X is going to be 0.1, meaning that this is the what was the question? The question was saying that the average rate, so it's going to be rate is going to be, what is this? It's going to be moles per decimeter cubed per second. Moles per decimeter cubed, moles per decimeter cubed per second. Yeah, basically that is supposed to be the answer. And then when you go to the next question, okay, they're saying that Maxwell distribution curve for dinitrogen tetraoxide initially present in container is shown below. All right, the initial concentration of dinitrogen tetraoxide is now increased. Okay, redraw the distribution curve above and in the booklet, and then label it P when you increase the concentration. The moment you increase the concentration, it means that you are increasing the number of particles. Yes, since you're increasing the number of particles, what is going to happen is you're going to increase the number of particles which are, yes, the number of particles which the rate is going to increase, therefore it shifts. Let me explain it like this. The rate is going to increase. Why? Because so it shifts to the left. So the number of particles, activation energy is going to remain the same, but the number of particles are going to increase. When the number of particles increase, it means that the number of particles with sufficient energy also going to increase, meaning that the graph is going to look like this. You see? Yes, meaning that it shifted from here to here. What if it was temperature? Temperature, yeah, it was supposed to be like this, I think. Yes, but for this one, yes, temperature does not increase the number of particles. No, it increases the particles which have sufficient energy. But this one now increases the number of particles. It increases the number of particles, and then what happens? It means that these particles will have, many will have sufficient energy to react. You understand? Yes. So they are saying that on the same graph, sketch the graph that will be obtained for the higher concentration. Okay, redraw the graph, answer booklet, and label it P. So we have done that. They're saying, will the rate of decomposition of dinitrogen tetraoxide at a higher temperature or concentration, be higher, lower, or equal to original rate of decomposition? Explain your answer. It will be higher than. Why? Because you have more colliding particles. If you have more colliding particles, it means that more particles will have sufficient energy to form products. Hence, the rate of reaction is gonna increase. Yeah, so basically, that's what you're supposed to explain. Question number 6. Question number 6. Guys, I'm going to stop here. Thank you very much. We're gonna start, when I come back, we're gonna start with question number 6. We do the calculations. We go to question number 7. We do the calculations, or do we answer them? I explain them, and then we go to question number 8, and then we go to question number 9. Thank you very much, guys, for joining me. Don't forget to subscribe, like, and share to others for our daily new videos. M. Saidi, as usual. Look at energy changes in reaction related to bond energy changes. So it means that you're going to be looking at the bond, what energy is found in the bond. And then number 2, we are going to look at definition of heat of reaction, and then exothermic and endothermic reactions. We are going to look at them in detail and then try to understand them better. And then we are going to look at the classification. That is with the reasons. You don't just classify. If you say it is endothermic, why do you say it is endothermic? If you say it's exothermic, why do you say it is exothermic? So that's what we are going to look at. Activation energy. Here is there is a very big point which you need to know, because some students try to confuse the activation energy and kinetic energy. So students try to confuse them. So another one is we're going to look at the graphs. We are going to try to interpret them. We're going to try to interpret them and then see exactly what is really happening. Why do you say this is endothermic graph, this is exothermic graph? So all those we are going to look at them so that we understand them better.
Okay. When there is a reaction, there must be heat either absorbed or released. When heat is absorbed, then we will say that that reaction is endo. We will see it. And when heat is released, then it means that that reaction is exo. When you say exo, it means out. Endo means in. In, you are taking in. Exo, you are taking out. Okay. Energy is absorbed or released in a chemical reaction. Whenever there is a reaction, even if you are fighting, there will be some energy absorbed. One must release the punch, one must absorb the punch. So there must be an absorption and there must be a release. So one must release, one must absorb. So if there are two chemicals, one must absorb, one must release. And then the total, how much is released, how much is absorbed, then we will know that the reaction, the whole reaction is either endothermic or exothermic. For example, you have reactants A and B. You combine them and then you form the products C and D. What will happen? The reactant particle need energy so that they need energy, yes, so that the existing bonds, it could be covalent bond, it could be ionic, it could be metallic, any kind of bond which is there between these particles can break. They will need energy so that you can break those bonds, and then after that you will form a product. So for a reaction to take place, energy must be present so that they can break down the bonds and then a reaction can take place. Energy is released by particles as new bonds form when the products are being produced. So now, when the energy is released by particles, then it means that some particles are going to use this energy to form the new bonds. As bonds are being broken, energy is released. Look at this. A reaction of petrol. Petrol will produce heat. It will produce fire. But petrol cannot burn without fire. I don't know whether you understand what I'm saying. You have petrol. Petrol, if it is just there, it cannot burn unless you ignite the petrol so that it can burn to produce more fire. So petrol to burn, the reaction to take place, it will require energy. That is the energy you're talking about. But now once the reaction starts, now the energy is too much in there. Now the reaction starts to continue, and then more energy is released. Now we subtract the energy we applied, and then we know that either it is endothermic or it is exothermic. So whenever bonds are formed, energy is either released or it is absorbed. Yes. So now we're saying that change in energy. How do you calculate the energy? The enthalpy, the H or delta H, or change in H. This is energy change, enthalpy. So is equal to energy of the product minus the energy of the reactants. So now if it was petrol, yes, you ignite it. The amount of energy you used, yes, as the reactant, that is the initial, yes, minus the amount of energy you produced at the end of burning process. There is amount of energy which has been released. So if you bring that amount of energy which has been released at the end minus the amount of energy you put in, then you get what you call the enthalpy change, and then we will know either this will be negative or it will be positive. It's like a business. You put in capital and then after that you get the profit. But profit, how do you calculate the profit? You're gonna say what you have gathered, what you have got at the end of the business minus what you put in, and then you get the profit. That's it. It's the same story here. Energy change, what you produced minus what you put in, then you get the energy change. Guys, don't forget this. Sometimes we say that energy of the product minus energy of the reactants. It's the same thing. If you find equations like this, it means that enthalpy change. And then sometimes you say energy final minus energy initial. It still is the same story. It's just a different way how we can express these equations. Or we can say you can write it in this way, yes, or you can write it in this way. Substitution, it will make you earn a mark. So it means that the final, you substitute it nicely as the final product or final energy and minus the initial. Make sure that you substitute it nicely and read the question nicely so that you can obtain the information which is being asked nicely. Then now let's look at the types of reactions. Types of reactions. We said that number one, we have what you call the exothermic reaction. Don't make noise. Okay, let's continue. And then you're saying that endothermic reactions, which result in absorption of energy. So when you have absorption of energy, when energy has been absorbed, then it means that is endo. It goes inside. Endo means inside. Thermic means temperature or heat. So it means that heat has been absorbed inside. Okay. Now, note, you need to know about this. More energy is released when new bonds form than is absorbed when existing bonds break. I repeat, more energy is released when new bonds form than is absorbed when the existing bonds break. Then it means that when there is bond formation, more energy is what is released. And then when there is bond breakage, it means that more energy is what is less energy is released. More energy is absorbed when the existing bonds break than is released when the new bonds form. So we are saying that the energy is absorbed when the existing bonds break. It means that you require more energy to break. You require more energy, you require some energy to break the bonds. Yes? And then here, you don't require energy to form the bonds. That's why more energy is released. And then here, more energy is absorbed. You require more energy so that you can break those bonds. Yes? We will see these ones when we go to the graphs so that you can understand it more accurately. Let's look at exothermic reaction. When you talk about exothermic reaction, look at this reaction. You have the enthalpy change of the reactants must be greater than the enthalpy change of the product. Therefore, the enthalpy is always negative. Okay, the enthalpy change of this reaction, for example, let me use this equation as I'm explaining this. Okay, if you are starting with the core, which is carbon, you add the oxygen there, then you produce carbon dioxide. Some heat is released here. Yes, it starts to burn. Yes, so the products will have the energy, the ash which you get will have less energy. That's why if you try to burn them again, the energy is no longer there. Yes, the energy in the ash will be less than the energy which was there in the core. That's why you're saying that the reactants will have more energy than the product. Because now we are saying that the enthalpy change is product minus reactants, and then now the reactants are bigger than the products, then the enthalpy change must be negative. That's why you have a negative answer here. So whenever the enthalpy change is negative, then the reaction is exothermic. I repeat, and let me repeat it again. And then make it more clear so that you can see what I'm talking about. Okay. We are here. We are saying, I'm repeating, that if you have a reaction whereby the products have less energy and the reactants have more energy, it means that energy has been released. You start with a high energy and then you end up with a low energy, then it means that there will be where some energy has been lost somewhere. So now, if you have a reaction like this, yes, you have a reaction like this, and then you have coal combined with oxygen, then you have carbon dioxide, then it means that some energy has been lost as heat. So when some energy has been lost as heat, what will happen? Then it means that the reactants will have more energy, and then the products will have less energy. And then if you subtract the products from the you subtract products minus the reactants, then it means that the answer is going to be negative. Why? Because the reactants are bigger than the products, and then the enthalpy change is going to be negative. That's why we say that the net energy leads to the surrounding in form of heat. That heat is released to the surrounding. The net energy, some energy has been released to the surrounding and then makes the products to have less energy. Hence, the reaction becomes exo because energy has been released to the surrounding. So, delta H negative is always an exothermic reaction. I repeat, delta H or change in enthalpy, whenever it is negative, we say that that reaction is exothermic. If you look at this graph, it's trying to explain what really happened in the exothermic reaction. Look, you start with a high. If this is 0, this is 2, this is 4, this is 6, this is 8, this is 10. You find out that the products, this is the product, because you start from here, then you have to overcome the activation energy. We are going to explain that, and then you end up here, the products. So the reactants have more energy. You see here is higher, and then the products, their energy is what? Is low compared to the reactants. So it means that where is this difference? This difference, the amount of energy which has been lost to the surrounding, which we call change in energy, or delta H, or change in enthalpy. So if they ask you to calculate the enthalpy change graphically or from the graph, then you find this point, the final product, you note it, maybe it's 2, and then the initial, which is maybe it's 4. So it's 2 minus 4, then you get the answer, which is maybe 2. But in this case, because 2 minus 4 is equal to 2, which is a negative. So the magnitude is 2. Negative means that it is exothermic. It released some energy. So that's why you see it here that delta H is less than 0, or 0 is greater than the delta H. So the answer must always be negative. This is A, and then you're saying that A is a reactant. I accept this is a reactant, but it's a reactant for the forward reaction. If I'm going like this, then A is going to be a reactant for the forward reaction. We're going to be talking about forward reaction and reverse reactions in chemical equilibrium, but if you don't know what you're talking about, then chemical equilibrium is going to be a problem to you. So now we are saying, I'm repeating now, this A is a reactant for forward reaction. We call this A is a reactant. Whatever is here is a reactant, but for a reaction which goes like this. Wonderful. But we say product, it can also be a product for a reverse reaction. Now, if I'm starting from here and then I come back like this, now this one is going to be a product for a reverse reaction. I repeat, if they ask you identify the product, they have not told you identify the product for a reverse reaction. No, if they say identify the product or identify the reactant, you just have to give me for a forward reaction, that a reactant is this and the product is this, unless they have specified that identify the reactant or the reverse reaction. Saying that unless they say that identify the reactant for the reverse reaction, then I will say that, okay, because I'm reversing, I'm starting from here, then I go back. So this one becomes the reverse reaction. So it becomes, this is the reactant for the reverse reaction, and then this is the reactant for the forward reaction. B, product. So B is a product for the forward reaction. So if I started from here and I go like this, then this becomes what? It becomes the product for the forward reaction. But we say reactants for the reverse reaction. So if I reverse it, then now B becomes the reactant for the reverse reactions. Okay, then we are looking at C. C is what called the activation complex. Yes, C becomes the activation complex. Before the reactants form products, they must form what you call the activation complex. Yes, without a catalyst, then it is much more higher. With a catalyst, it is a bit lower. We'll explain why these come like this when we go to the factors affecting the rate of chemical reaction. So activation complex, it means, what does it mean? It means, for example, let me say, Loloetu is going to fight with Aviwe. So when they are going to fight, what happens? They don't just fight. No, there is a time when everyone has energy and you see that even the face has changed. Yeah, whoa, now you know that, yeah. So they're about to fight. Then when the time when this one brings a blow and then also this one brings, that time before collision, but just towards collision, that is the activation complex. So now you have A and B, they react. When they react, they are going to react. There's a time when the bonds are, the reactants are almost together and there is some attraction between the two products. So we call that one activation complex. The moment they touch each other, now they exchange, then they form the what? The products. But to form a product, you need a specific amount of energy. You don't just, you can provoke someone, there's provoke 1, 2, 3, but can't fight. But the moment, the energy is enough, then they fight. So activation complex, it is that period when the bonds are almost linked. Then the activation energy, that's the energy the reactants must have so that they can convert into products. So without that energy, they cannot convert into products. Meaning that without that energy, these two people cannot fight until they reach that energy, then they start to fight. Then we are saying that activation complex with a catalyst. When there is a catalyst, you know that, for example, Aviwe wants to fight with Loloetu, and then what happens? Tabiso comes and says that, Mofukenge comes and says that, Aviwe, you can't beat this Loloetu. You can't beat her. Then what happens? Now Tabiso starts to bring in. So it means that Tabiso makes the energy to be fast. So the activation energy to be a little bit lower. And then they will fight. Instead of fighting after maybe 10 minutes, they're going to fight within 3 minutes. And then the fight is already there. So the activation complex with the catalyst tries to lower the energy. That's why you see it here. That the one with the catalyst, it is lower. And then the one without catalyst is a little bit higher. And then the endothermic reactions. When you talk about endothermic reactions, these reactions, you'll find out that it is the reverse for the exothermic. The reactant energy is less than that of the product. It means that the products they have more energy than the reactants. Meaning that the activation energy, meaning that the energy has been absorbed. The energy has been absorbed, and then the enthalpy change is always positive. Why? Because the products have more energy than the reactants. If you say products minus the reactants, you get a positive answer. That's why we say that delta H, or change in energy, is greater than 0. It means that it will never be negative. When it is negative, then we say it is exothermic. And then you're saying that here is the formula whereby you say that products minus reactants. Yes, obviously the answer you get here must be greater than 0, which means that it must be positive. net energy is absorbed. Since you have reactant A and then you have product B, then product B has absorbed the energy, then obviously the energy is going to be a little bit higher. So energy is absorbed from the surrounding in the surrounding in the form of heat. And then what will happen? What is the best example here? The best example here for exothermic, endothermic, yes. You in winter you try to bath warm water, yes, isn't it? So when you bath warm water, you feel a little bit hot. Yeah, you feel a little bit hot. It means that the body has absorbed the heat. Wonderful. That is endothermic. You have absorbed it. Hey, but okay, don't cover yourself. Leave yourself just like that. After some 1 minute, what will happen? Now you start to feel cold. What does it mean? Now the reaction has reversed. Now the heat is being released to the surrounding. Now it becomes exothermic. Now it means that you are releasing the heat to the surrounding. So the reaction can be reversed. You take in, if you don't take care, then it reverses, or if it becomes full, then it reverses, then it comes back. When you eat, another example, when you eat, just eat. You eat, you take in energy, So we say that is endo. But what will happen? If you overeat, then you regurgitate, you start to vomit, then now that is exo, you release out. After releasing, whenever you release, you feel much more better. That's how it is. And whenever you take in, you feel uncomfortable. That's why when people overeat, they feel uncomfortable. But once they release, they feel much more better. There are so many examples where you have these things in the day life. When you go to the toilet, you are exothermic. You are releasing the heat, isn't it? After the toilet, you feel much more better. You feel happy, and everything is moving smoothly. I'm not saying this embarrass you, but that's what is happening. And these are the reactions. These reactions, you know them, but sometimes you don't take a keen eye to see that these reactions are happening in real life. Okay. Example is, now we are going back to the chemical way. Example is dissolving ammonium nitrate. If I was at school, we would have done these reactions and then we see them. And unfortunately, corona is the problem. Okay. We are saying that example is ammonium nitrate in water. When you dissolve ammonium nitrate in water, you will find out that the reaction is endothermic. It takes in heat. Okay. Before I explain this, I'm going to ask you.
It's just a friendly reminder that like our video. And don't forget to subscribe for next free videos. At Thundereduc.
Increase in the temperature of the reaction. So we are saying that you have two graphs, graph A and graph B. This graph shows that at a higher temperature, the graph looks like this. At a higher temperature, the graph looks like this. And then at a low temperature, you'll find out the graph looks like this. So what is the major difference between this and this? Why is at a higher temperature it looks like this? So this shaded part shows the particles which have enough energy or more than the activation energy so that they can react. So if you look at the number of particles here, if you draw a line here at a low temperature, you find out that only these particles from here to here have enough kinetic energy to react to form into products or more than activation energy. But if you look at this, the number is bigger compared to this. So it shows that here there are few particles which have enough kinetic energy to convert into products. But here it has more particles which can be converted into products. So when you increase the temperature, you are increasing the kinetic energy. You are increasing the speed at which these particles are moving. Increase in the temperature, you are increasing the speed at which these particles are moving. And then this causes more collision. So if the temperature is too high, then it means that there's the activation energy is going to be lowered, or many particles will have more kinetic energy, and then they can be converted into products. That's why you see here that here the reaction or the graph is covering more particles if you draw a line here, and then here it is covering fewer particles. So it means that if you have more kinetic energy, it means that the particles which are going to react are going to be more, and then more products are going to be formed. So increase in temperature increases the rate of chemical reaction. So at higher temperature, the graph is wider and most probably energy is higher. So if you look at it, the graph is wider. It means that it has more particles which can react, which have enough energy, and then the number of additional particles with energy or is greater than the activation energy, therefore enough energy to react or to react with the other reactants. And then this one shows that the most probable energy at low temperature. So at low temperature, this is the most probable energy, and then the most probable energy at high temperature. You see that the energy here is, look at this, you see that the particles have a lower energy, kinetic energy. And then if it is a higher temperature, you find out that the energy increases from this point to this point. If this is 0, 2, 4, 8, 10, you find out that this one will have like 8 and this one will have like 12. And then it means that it has more. If it is at higher temperature, it has more kinetic energy. So that's how we can explain this graph. At a higher temperature, the average kinetic energy is higher than at a low temperature. So at a higher temperature, the kinetic energy is higher than, if you look at this is a low temperature, this is at a higher temperature. You see that the speed at which these particles are moving is lower than the speed at this one at which these ones are moving. So when there is a high temperature, then there will be more kinetic energy, and this more kinetic energy will make the collision to happen. So if you look at these ones, you see that anytime they can collide, but these ones, they are slow. The speed at which they are moving is too low, then it means that the rate at which they collide is going to be low. So we are saying that more particles have kinetic energy greater than the activation energy. So if there is a high temperature, you find out that there will be more particles having more kinetic energy greater than the activation energy. And the moment the energy or kinetic energy is greater than the activation energy, then the reactants are going to be converted into products. More effective collision will take place per second. Then it means that reactants can be converted into products. Another factor is the effect of increasing in the concentration of the reactant. Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel. Volatile cells. Last time we talked about electrolytic cells. We say that electrolytic cells, for them, they require external battery. So if it requires external battery, it means that they are not spontaneous. They cannot continue on their own. So they have to be with an external battery which can supply energy to them. And we say that an electrolytic cell, it changes electrical energy into chemical energy. And then the voltaic cell or the galvanic cell, yes, this one, it's the reverse to electrolytic cell. A galvanic cell, it changes the chemical energy into electrical energy. It means that it produces electricity. All right, let's start. So we are saying that a galvanic cell or a voltaic cell is a cell in which chemical energy is converted into electrical energy. It means that use chemicals to produce electricity spontaneously. It means that without any external source. It means that these chemicals are converted into electricity. A cathode is positive. Remember, in electrolytic cell, cathode is negative. And then anode is negative. Remember, in electrolytic, anode is positive. So remember that electrolytic cell, it is the reverse of the galvanic cell. Reduction
takes place at the cathode. This one remains the same as even in electrolytic cell. And then oxidation occurs in anode. Still is the same thing with the electrolytic cell. Strong oxidizing agent is put on the cathode. When you say oxidizing agent, guys, don't remember, when you say oxidizing agent, how about it? What is happened to it? It means that if it is an oxidizing agent, for it is reduced. So it means that it's less reactive. It can accept the electrons. Yes, it can accept the electrons. If you are broke, it means that you can accept everything. Yes, so you oxidize others. You make others to be broke. All right. So we are saying strong oxidizing agent, it means that they can accept the what? The electrons. For them, they are reduced. So they are you put them on the cathode, the positive. Because cathode is positive, so they are able to receive electrons from what? From a strong reducing agent, which is put on the anode. Anode is negative. Then it means that the strong reducing agent, for it, if it is a strong reducing agent, then it means that it is oxidized. It is able to release the electrons. It increases in the oxidation state. When you lose electrons, you become more positive. You become more positive. Yes. When you give credits to others, you become more rich because you know that anytime that money is going to come back to you. All right. So we are saying that we put it on the anode. So you have to understand this, because if you don't understand this criteria, then you won't be able to understand the concept of volatile cells. So I will say that this is a red cat. This is a red cat. This is a red cat. So don't forget that. I'll tell you what it means. All right. So we are saying red cat. What does it mean? Reduction at the cathode. Reduction at the cathode. Consider, now we are going to have an example. We are going to have different examples. Consider copper zinc cell. If you look at them, you'll find out that one is more reactive, one is less reactive. If you look at the reactivity series, this one is less reactive, this one is more reactive. A strip of zinc metal is placed in the zinc ion solution. A strip of copper is placed in a separate beaker in aqueous copper 2 solution. So you have copper, you have zinc metal in zinc solution, and then you have copper metal in copper 2 solution. All right, here is an example. You have zinc. So there is a reaction which takes place here, and there is a reaction which takes place here. Yes? We say that zinc is more reactive. It is oxidized. It can release the electron easily. Therefore, it causes this one to be reduced. So this one becomes a strong reducing agent. Yes, strong reducing agent is supposed to be at the anode. Then copper is less reactive. We're going to look at the reactivity series. And then copper is less reactive. Yes, if it is less reactive compared to zinc, then it means that it's ready to receive from zinc. So copper is ready to receive. To receive what? Electrons. You see them? See them, yes. You see them. Yeah, electrons. So it means that zinc is going to cause this to be reduced. Therefore, zinc becomes a strong reducing agent. It's supposed to be at the anode. And then copper is going to receive the electrons from zinc. Therefore, it's going to be reduced. Therefore, we will say that copper has caused the zinc to be oxidized. Therefore, we shall say that copper is a strong oxidizing agent. Why? Because it has made zinc to be oxidized. That's the meaning. So this is the half cell for zinc and half cell for copper. These two beakers are connected by a salt bridge. salt bridge is very important in giving these two cells ions. We're going to look at them and you will understand them better. All right. Should we continue? Yes. So we are saying that they have a reaction that occur in each half cell. This is what happens. We say that zinc is more reactive. Yes, it is a strong reducing agent. So it means that for it is oxidized. You start from zinc, the charge is 0, and then here the charge is 2, positive 2. Yes, so it means that this zinc gives out zinc ion plus 2 electrons. This equation must be balanced. Yes, you see, why do we put a 2 here? Because this is positive 2. So if it is positive 2, yes, this positive cancels with the negative, and then the equation becomes neutral. Remember, matter is neither created nor destroyed, but can be changed from one form to another. Yes, so your equation must obey that law. And then copper is going to receive these electrons. Yes, it is copper solution. Yes, it's going to receive the electrons. Yes, these electrons from zinc, and then it forms copper. There is something which is supposed to be noted here. If zinc dissolves to give zinc ion plus electrons, it means that this zinc electrode reduces in size. It means that the anode always reduces in size. Why? Because it dissolves to give out the electrons. It is supposed to be reducing in size. Then copper receives these electrons. Yes, and then what happens? What is happening? The ions here, the electrons from the zinc combining with this copper, yes, to form copper to ions to form copper solid. It means that copper, the copper will increase in size. You see, it will increase in size. Why? Because it forms a solid. Yes, if it forms a solid, then the cathode is always increasing in size. There's something we need also to understand better. Because now the copper ions are being used from the solution and then form a solid, yes, it means that now the solution will start to fade out. Yes, to be fading. Why? Because the copper ions which make the solution to be blue, they are being used up. Therefore, now the solution becomes pale. It fades until it becomes clear. Once it becomes clear, then it means all the copper ions have been used. So you need to know those small concepts so that when they bring the question, you are able to answer them nicely and clearly. So, all right, let's compare. Let's compare the two half cells. Yes. Number one, zinc half cell. Then copper half cell. The one we have talked about, oxidation reaction at the anode, which is always negative electrode. We know that anode is always a negative electrode. Yes, so oxidation occurs there. It means that zinc will ionize. Yes, when it ionizes, then it increases in the charge. Then obviously reduction will occur at the cathode, and it's always a positive electrode. This one is supposed to be a reducing agent because it causes this copper to be reduced. Yes, and then itself it is oxidized. When it releases electrons, you see, it releases electron, comes from 0 to 2. So it has been oxidized, increase in the state. While this one, it has accepted, therefore it's a strong oxidizing agent. It has caused this one to be oxidized. And for it, it is reduced from positive 2 to 0. You see, it has been reduced. And it has caused this one to be oxidized. It is a strong oxidizing agent because it has caused this one to be oxidized, and itself it is reduced from 2 to 0. That's the meaning. Then when you go to zinc, okay, the equation, this is the equation, what is happening, we saw it nicely, and also this is what is happening, we saw it nicely. Yes, so you read from right to left. We're going to look at it when we go to the reactivity theory, and then here read from left to right. You're going to look at it when you go to the reactivity theory. All right, so when you are writing the cell notations, we're going to look at it and then you're going to get it better. All right, We are saying that zinc is a strong, zinc is the stronger reducing agent, while copper 2 is a stronger oxidizing agent. I've explained this. How is this is a strong strong oxidizing agent? Because it causes zinc to be what? To be oxidized. Then it becomes an agent for oxidizing. But itself is what? Is reduced. And then zinc is a strong reducing agent. Yeah, it is an agent for reducing. So it causes copper to be reduced. But itself is done what? Is oxidized. Then we are saying that the anode always decrease in mass if the reducing agent is solid. I've tried to explain it that if you look at zinc, because zinc is dissolving into the solution, then the mass must be reducing as long as it is this electrode is a solid. So it means that it keeps on reducing in size. It is corroded. Yeah, it starts to disappear. All right, and then they're saying the cathode always increase as long as it is a solid, always increase in mass if the reduced product is a solid. Yes, so we saw that since copper is a solid, if you look at it here in the equation, copper is a solid. Even you can look at it here. Yes, is a solid. Then it means that the terminal must be increasing in size always as long as it is a solid. Since now you know the concept, now it means that we can apply these concepts in different versions. All right, net cell reaction. It means that we're going to combine the half equations and then we see what we're going to form. Make sure they have equations balanced. Balance them, including the electrons. I try to show you on the equation that the electron must be balanced. Add the two half reaction together, eliminating the electrons from both sides. So that now when you add them, then you eliminate the electrons and then it cancels out, then you form a full equation. Let's look at it. Here is oxidation, which is taking place on this side. Yes, on this side of the half cell. Zinc metal, yes, or solid, dissolves to give zinc ion plus 2 electrons. The 2 electrons, they start to move. These electrons, they will come to this side. So what happens? This one will receive. We'll receive these ones here. When they come here, and then they combine with this copper. So copper 2 ions plus 2 electrons, which came from zinc, and then you form copper solid. So this one forms a solid. It is deposited here. While this one starts to dissolve, which is this, dissolves and then becomes small. Becomes small, becomes big. Husband and wife, one must be becoming smaller, one must be becoming bigger. All right, let's continue. I don't know what is happening in your family. If your father is becoming small or your mother is becoming small, then one must be oxidizing agent, another one must be a reducing agent. All right. Maybe you are the one, you kids, who are making them to be oxidized. Or to be oxidized, or to be reduced, whatsoever, I don't know. All right, net cell reaction. So now how do we form? You have reaction which is taking place here, reaction which is taking place here. So arrange them like this and then start cancelling what is. So I check what is before the arrow compared to what is after the arrow. Zinc solid, this side before the arrow. Do I have it? I don't have a zinc solid. I leave it. I go to copper ions this side. Yes. Do I have copper ions this side? No, I don't have it. I have 2 electrons. Yes, I have 2 electrons here. Do I have 2 electrons here? Yes, I cancel them out. So those ones, they go. I come this side. I have zinc 2 ions. Do I have zinc 2 ions? No, I leave them. I have copper 2 solid. Copper solid. Do I have copper solid this side? No, so I leave them. So now I combine zinc plus copper 2, zinc plus copper 2. This is a solid, this is aqueous. Always, whenever you have a charge, it is aqueous. You should just have to know that. Then the arrow, yes, and then I have zinc 2 aqueous plus copper solid. these ones they cancel it. That's how you can write the full equation. Simple. Know what is a anode, what is a cathode, find the equation there. One must be reduced, one must be oxidized. Find the equation, write the equation down, then combine them. Simple. No stress. Then, salt bridge. Part of an electrochemical cell. It's usually a tube. It's usually a tube. It can be containing electrolyte, providing electrical contact between the two solutions. So we are saying that it's a part of electrochemical cell. Yes, usually it's a tube. It means that the chemicals are being put into the tube. Containing an electrical conduct. It must be containing an electrolyte. It must be containing an electrolyte. It means that it can, the substances you have put there, it must be able to conduct electricity and it should be able to release the ions. Actually, if they can conduct electricity, then it means that it can release the ions and electrons. Providing an electrical contact, it means that there is a contact. It's not physical contact. It means electrical contact. Then it means that ions must be exchanged there. It's like an exchange. Functions of salt bridge. Number one, it completes the circuit. Simple. Anode and the cathode are being connected. That salt bridge must be there so that the circuit is complete. Number two, it keeps the two electrolytes in the two half cell separate so that they don't mix. They must not mix. However, it ensures electrical neutrality. So these two must be neutralized. If they are not neutralized, then it means that the cells will be impaired. The cells will not work. They will not work anymore. So what they do, they bring about charge, it brings about ion exchange. It brings about an exchange. So by doing that, it ensures that an electrical neutrality is obtained in that cell so that the ions are neutralized so that the cell can continue working or functioning normally. All right. Number three, this allows movement of ions between the two electrolytes from the cathode cell and then the anode cell. The two must be able to communicate with one another, even if there is a distance, so the salt bridge connect them. Note, electrolyte in the salt bridge must contain ions, which are weak. They must be weak reducing agents and must be weak oxidizing agents. The reason why they must be like this, so that they don't take part in being oxidized and being reduced. Because if they take a part in being oxidized and being reduced, then it means that they are going to be used up. So then the reaction will stop. So they must be strong, so very weak reducing agents and must be very weak oxidizing agents so that they are suppressed by the other ones. This will ensure that ions are not oxidized nor reduced, but act as a spectator ions. So it's just like to neutralize, to bring about neutrality. It's just like that. Nothing else. It's just to connect. So these are the functions of the salt bridge. 1, 2, 3. Let's continue. Very simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning about it.
It's just a friendly reminder that like our video. And don't forget to subscribe for next free videos at Thundereduc.
Adding a catalyst. So what will happen to a catalyst? Remember, catalyst can increase the speed or can reduce the speed. So the suitable positive catalyst, it will lower the activation energy, and then more reactants are going to be converted into products.
then you're saying that more particles have enough energy to form an activated complex. So the activated complex, that molecule which is in transition to change from reactants to products, you're going to have many particles which can form that, and then more products will be formed. Therefore, the number of possible effective collision per second is going to increase. And if it increases, then it automatically the rate of chemical reaction is going to increase also. So the number of possible effective collisions per second increases, and this therefore increases the rate of what? Chemical reaction. So a catalyst increases the rate of chemical reaction by lowering the activation energy. So here you have the number of particles, here you have the kinetic energy, here you have the kinetic energy without a catalyst, and then here you have activation kinetic energy at with a catalyst. So it means that this reaction has been catalyzed, this one is not being catalyzed. So the number of additional particles with energy greater than activation energy, therefore enough energy to react. So if you look at this, I say that catalyst does not change anything here. It only lowers the activation energy. So if it lowers the activation energy, then it means that even those which couldn't react, now they have the ability to react. Then this leads us to the techniques we use to measure the rate of chemical reaction. Welcome back to our class. Don't forget to subscribe if it is your first time to visit our channel.
Simple. Electrolyte. Let's look at now electrolyte in simple term, and then we understand it better. So once you understand it better, then you'll be able now to combine all of them, and then you go for any question concerning about this. The salt of the compounds need to be soluble. It means that they need to be able to dissolve in the solvent. For example, water. Yes, it must be able to dissolve. The suitable soluble salts of zinc and the copper are, for zinc, it's better to use zinc nitrate. When you're talking about the chemistry of nitrates, all nitrates are soluble. They are able to dissolve. And the copper nitrate, So these are the solutions. So on the side of the half cell of the zinc, you put zinc nitrate solution. And on the side of a half cell of copper, you put copper nitrate solution. That's what it means. So in here, zinc nitrate solution, and then in here, you put copper nitrate solution. Now someone will ask you, but you talked about copper sulfate. Yes, but they are saying the suitable. You can use any other, but the suitable, the one which is much more better is that. Zinc is oxidized to zinc ion. You know that? And the concentration of zinc ion increases. Now look at this. How is the salt bridge very important? Let me just open your mind so that you know where we are going. Zinc is oxidized to zinc 2 ions. The concentration of zinc 2 ion increases, yes, building up a positive charge. So the concentration of zinc ion is here, yes? Yes, they increase because it dissolves here. The electrons will move away from the negative potential. Remember, this is a negative potential. And then it goes to where copper is here. They go. When they go, they come this side to copper. What happens? The electron will move away from the negative potential, yes, the terminal, making it impaired. It means that now we have too much positive here. Remember, this is supposed to be a negative terminal. And then now you have too much positive. What will happen? Then it's going to be impaired. We need something which is going to neutralize this. This is a negative terminal, but now the positive charges are building there. So what is supposed to happen? Yes, we need to keep it negative, because if you don't keep it negative, it's going to turn into a positive, and then the reaction is not going to take place. All right. So copper 2 ion. So what is happening to this? We're going to look at the solution for this. But copper 2 ion are reduced. When they are reduced, they form copper solid. Wonderful. Then you are saying that the concentration of copper 2 ion decreases. It means that now when it comes like this, these electrons, they react with copper 2 ion. Remember, I told you that now it starts to fade. Yes, because we have used all the copper 2 ions. So the concentration of copper to iron decreases. This leads to copper to becoming less positive. It becomes less positive because now the positive charges have been used up. It has formed a solid. And remember, this is a positive terminal. So if the problem comes in now, what is happening really? So we have to make sure that this one remains positive. The electrons are therefore not attracted. It means that now these electrons from this side of zinc will not come to the copper. Why? They are no longer attracted. Why? Because now the copper to ions have been used up. It's no longer that strong positive side. Then what happens? Attracted to the cathode as strongly, making it impaired. It means that it can't work anymore. So what happens? We have to look for a solution for impairment of the cell. So what should we do? Number one, we are saying that the migration of nitrate anions is a negatively charged particle. Yes? Negatively charged particles are called anions, and positively charged particles are called cations. So we are saying that the migration of nitrate anions in this salt bridge to the anode. Remember, we say that here this one becomes it forms this, yes, and then it becomes more positive. It reduces the negative part of it. So what we need to neutralize this. So because it is positive, it is zinc to ions, yes. What is happening? The zinc to ions have accumulated, so we need a negative anion. Where is it going to come from? It's going to come from the salt bridge. Potassium ion, remember it is made up of, the salt bridge is made up of potassium and nitrate, yes, in the salt bridge to the cathode. So it means that this one will go to the anode, while this one will go to the cathode. Yes, it is potassium nitrate in the salt bridge. So what happens? It means that the positive will go to the copper, and then the negative will go to the zinc. Let's go back here and we see. We say that this one accumulates. When it accumulates, it forms more positive. So we need to reduce it so that it goes back to a negative terminal. So we send it potassium, we have potassium nitrate. We send here the nitrate. So it neutralizes this. So it means that now this terminal remains negative. Now here, when this one comes in, when it comes in, it uses this copper 2 ions. When it uses the copper 2 ions, what is now happening? It's gonna make it lose its positive ability. Yes? So what do we need? We need a positive charge to come here. Remember, it is potassium nitrate. The nitrate has come here and the potassium is positive. So the potassium will come this side and then makes this one to be positive. So it means that now the terminal will be able to attract more electrons. That's it. That's how you can explain. You're saying that this cancels this build up of undesirable charge, maintaining the cell's electric neurality. It means that it will be neutral. There will be no more this fluctuation in the polarity, and the negative will remain negative. That is the function of the salt bridge. That's why we say that it brings about what you call neutrality. All right. So we are saying that the cell, therefore, continues to form or to function properly. It is going to continue functioning properly without any problem. Electron current. Let's look at it now. Electrons are always moving from anode, from the negative terminal to a positive terminal, from zinc terminal to copper terminal, through an external circuit to the cathode. So it moves from the anode, zinc, to the cathode, which is copper. Then you're saying that in copper zinc cell, electron therefore flow from zinc to copper. I've tried to explain that. It means that it moves from a more reactive element, which is able to be oxidized, to a less reactive element, which is able to be reduced. Cell notation. How do we write now the notation? How do you write the notation? Always start with the anode. which is the negative on the left, and end with the cathode on the right. Cathode is the positive. Are we there? Anode, negative, cathode, positive. All right. Use this separator. Use this. Use a dash. Use a dash. Use this to separate anode or cathode. I'm gonna show you from its electrolytes. Represent the salt bridge. The salt bridge. When you use this two double slash, forward slash, because you have a back slash and a forward slash. The two forward slashes, yes, it means that you are representing a salt bridge. When you use one slash, it means that you are separating anode or you are separating the cathode. Components of the cathode and components of the anode. For example, zinc, which is a solid, slash, it means that it gives out zinc to ions. It means that it is oxidized, which is aqueous. Then I have a salt bridge, yes. Then the copper receives the electrons from zinc, remember? And then you have copper, 2 ions. When it receives the electrons, then it is reduced to copper. Then I have to separate it, that this copper give me copper solid. That's how you're supposed to explain it. Let me repeat. Zinc gives me zinc 2 ions. And then the copper 2 ions gives me copper solid. That's the meaning. What happens in the half cell of the zinc? What happens in the half cell of the copper? Electrode, this is the electrode, yes. Slash, the electrode, the solid dissolves into what? Into electrolyte. Electrolyte, it means a solution. Electrode, it means a solid. Dissolve into the solution by giving the ions. Yes, salt bridge. Now, what is in the solution? The copper 2, yes, which is the electrolyte solution. It gives me, or it gives the electrode, which is a solid. You understand? That's how it's supposed to be interpreted. Or you can say, this is what needed, but these ones are trying to explain. Anode, which is a negative, salt bridge, cathode, which is a positive. That's it means. All right. Here is what we are talking about diagrammatically. Zinc gives me zinc 2 ions. Yes. Zinc gives me zinc 2 ions here. Yes. Then I have copper. Copper 2 ions gives me copper. Is this? And then you have in between here, I have a salt bridge. Salt bridge which connects them. That's the meaning. Unless you have a question, next time we're gonna start with the standard electrode potential. Standard electrode potential. Make sure that you come to class on time.
On a weekly basis, which are going to help you to get a distinction. This is the only channel which you can use and get a distinction, because whatever we talk about is related to examination, and they expect them in your exam. Let's start with the objectives, and then we see how we can smash them. How we can smash them so that we can get at least distinctions. They're saying consider the structure formula below. If you look at this structure formula, yes, if you try to expand it, you'll find out that it is CH3, C double bond there, and then CH3. So they're saying structure formula. Identify the name of the functional group in this formula. So if it is a carboxylic acid, it's supposed to have at least that, yes. If a carboxylic acid or ester, so we don't have that. If it is still a carboxyl group, it's supposed to have the same functional group and the homologous series. So this is almost the same thing. So ketone and aldehyde or carbonyl groups, they are the same, but Don't forget that in here we have the aldehyde and ketones. So keton, well, we expect the carbon atom to be in the middle of two alkyl groups. So it means that there must be another carbon atom this side, another carbon atom this side. Therefore, this becomes a keton. It becomes a keton. But because they are saying the functional group, yes, because keton is a homologous series. Because they are saying it is a functional group, then automatically the carbonyl groups, the carbonyl group, yes, it has both the keton, and it has the aldehyde. So it means that the answer for this is going to be D. So you'll find out that many students will be putting C, of which C is not a functional group. C is the homologous series in that regard. Then they're saying that which one of the following is an empirical formula of 1,2-dichloro. So I expect 2 chlorides somewhere. And then dichloroethane. And then if this is ethane, so I expect it to have at least and then a chloride that side and a chloride that side. So if they're saying one chloride, the second chloride, on carbon atom number 1, carbon atom number 2. So if we count this, we will find out that you have, yes, 2 plus a chloride, 2, you see, 2 of them, 1, 2, yes, so I have C2, 1, 2, 4, so H4, yes, H4, and then 2 chlorides, which is going to give me that. If we have that answer, it becomes the correct answer, which is D. But because they're saying empirical formula, yes, when they say empirical formula, it means that you are talking about the simplest way how you can express this. The simplest way how you can express this. So now, because we can express this, this becomes now the molecular, the molecular formula. Yes. So now it means that if this is 2, 4, 2. 2 can go into 4. So therefore, if I divide by 2, divided by 2, divided by 2, I'm going to have CH2Cl. So if I have this in the equation, then it becomes the most correct answer. Therefore, B is also another correct answer. But because they want the empirical formula, the simplest way how you can express it, therefore this one becomes wrong, and then I get this to be the correct answer. So it's also a confusing thing if you don't take care of it. Then they're saying that consider the structure formula of the organic compound below. This is an organic compound below. So once you are given this, first identify its homologous series. You find out that it is an alkene. It has 2 bonds between the 2 carbon atoms. So now, since I know that it is an alkene, it's going to end with that. Now I have to find out the longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. So any of them is 5, and 5 is pent. But this pent, I need to know the position of the double bond. Is 1, 2. 1, 2, 3. So I'm going to take the 2 because 2 is a little bit shorter. 2. So now, if I say this is the, if now I say that this is the longest chain. Yes, so it means that now this, and this, they become the side group. Because I use this direction when I'm counting 1, 2, therefore I'm gonna have the first one is gonna be 1, 2, the first branch is on 2, 3, 4, the second branch is on 4, and then another branch is on 4. But because all of them are the same type, then automatically is going to have a tri. Tri has one carbon atom, which means mess, which is because they are side groups. Remember, whenever you talk about the side group, the two letters Y, L. So it becomes 2, 4, 4 trimethyl. And then the longest chain is pent, and the position of the double bond is on carbon atom number 2. So it's going to become pent 2 in. Don't forget that a figure and a figure, we separate them by a comma, and a figure and a letter, we separate them by a dash. That's why here it also figure a letter and a figure dash, a figure and a letter dash. So it means that that is going to be the answer. So now we come here and then we find out where is the answer. 2, 4, yes, trimethyl pent 2 in. So this one becomes the answer.